Hello, everyone. Let me remind. My name is Igor Urbanovich. I'm from AMGC community, and this is our conference. Again, we made preparation about 6 months, and now we are going to show you amazing technical talks. And today, you who join us, you are on orange stream, and we have second one, purple stream. On our platform via community, you can find schedule agenda of today's technical talks. So you can choose which one you're interested more and switch. All links in the description under this video you can find, of course. Moreover, to have a communication, we proposing you to join us in the Discord. Again, the link here. Join us, and after each talk, you will be able to ask questions by your voice if you want, or type it, and speaker will be happy to answer all of them. But it's not all. In the Discord, we are making some interesting quizzes, victorinas, and so on. So you can spend funny time and win interesting prize. This is license for JetBrains, for IDEA. I believe all of us are using this. Yesterday we discussed some popular in developers atmosphere topic. It's a type of idea. Which of mode you are using? Please write in comments which mode you are using. For example, using night mode, dark. And what about you? Write in comments. And I want to tell about our first speaker for today. This is Mykyta, and his talk named Serverless 2049. Oh, a huge work was done to prepare this talk because guys was needed to test different application written in different Java-based environments. We can find answer. Is Java not so performable as it was? and should we choose another one language, for example, for clouds? Or Java still great? So let's invite here Mykyta and Tatiana. Oh, you already there. Hi, Mykyta.
Yeah, hi.
So, couple words, please, about your speech.
Yeah, thank you for this introduction, Igor. Actually, yeah, topic is really holy war. When we are talking about serverless and Java, people may share completely different opinion about this topic, and I hope I will bring some piece of light to this discussion, or maybe make it even worse, and holy war will be even more bigger. So let's take a look.
And yep, my goal as a moderator today will be to sound your questions, guys. So please feel free to post your questions in any of channels which is comfortable for you. So it might be YouTube, Discord, or we are community platform, and we will be glad to sound your question and to answer them.
Yeah, colleagues. And you can, of course, not only questions type, your experience, for example. So what do you think about Java is good for clouds or not? For serverless. You can write right now if you have such experience. Okay, let's go.
So let me bring the slides on the table. Please say when you can see them. So they should appear.
Yep, we see it.
Yeah, awesome. So as you have said, we will be talking about serverless today. Actually, this speech called the Serverless 2049. Actually, for me, it's very excited to be here today with you guys. This is my first big conference. I have attended some small talks, but never have talked at the such high level. Actually, with such level of preparation, when you are joining, there is an operator behind the scenes. You don't know about this, so I had talk some secret to you. Yeah, and actually the level of organization is great. Thank you to the organizers. Thank you to Igor, Tatiana, and everyone who participated in the preparation of this talk. Before we start, I'm located in the Kiev, in the Ukraine, and right now the situation here is pretty, yeah, as you know, pretty hard. So organizers share with me the information about the foundation which they support. So if you are able and want to join and contribute some, we will appreciate a lot your donation and help to the Ukrainian medics. So this Leleka Foundation helping the injured and wounded people. So if you want to make something good and help us, we will appreciate this a lot. Yeah, so let's go further to the topic. As I said, Serverless 2049. Let me present myself. My name is Mykyta Berehulia. I am from the Kiev, as I said, working in the EPAM at position of senior software engineer. I am not yet McKinsey consultant, and yeah, I had done this research, this speech not alone. Some people had helped me, actually a lot of people. We have a community in the Kiev, Java lineup community. We are inspired by the Java and like to work with Java technologies. And that what I will show you had been done together. And you can see all the people who had participated actually directly in the writing code or some any other kind of technical contribution. So thank you also to all these guys. But let's get back to the topic. Some people had asked me why the topic called Serverless 2049. Is it something related to the Blade Runner and this movie? Actually, I will tell you in the end a funny story about this name. And actually, when we are talking about serverless, we see a future very dark. You may ask why, and I will answer you that we have received a message from the future. Yeah, actually, some kind of cloud time machine had bring us the message from the 2049, and I propose you to hear it right now.
Serverless 2049. Cloud providers are more dominant than ever. The last on-premise systems are down. The resistance, known as server owners, is fighting for the remaining money, trying to find the best approaches to utilize available resources.
Yeah. So as you understand, the people in the future, they're in pretty bad situation. So the cloud providers has conquered the world. And if you want to develop something and host it in some your on-premise service in your mom's bedroom, it's not available anymore. You should push everything to the cloud. And people are fighting for their money and trying to find the best approach how to utilize the available resources. So yeah, you're calculating each cent which you spend. And let me show you the second part of this message.
Start preparing resistance. Find the best and get ready.
Yeah, so the cloud providers are so strong that the resistance appear and the rivals are fighting back their money, and they ask us to prepare the best people to conduct the research how to survive in the cloud world of the future. So here today we will discuss you this topic and we will try to find the answer, and we will prepare to you so you will be able to join our resistance and work together with us. So be involved as much as possible. Okay, to be serious, this joke about the cloud providers trying to conquer the world is just built on the rumors. You know, people talks a lot that the cloud might be so expensive that you cannot afford it. Some other people says, wait, listen, cloud is not expensive. It's saving your money. Some of them says that the cloud provider gives you unlimited scale. You can use as much resources as possible. Some others says, wait. There is a limitation, limits, quotas, etc. So the everything is not so shiny. Some people may afraid that they will have vendor lock actually, and cloud will not allow them to move out. So you will stick in their technologies and will never be able to to switch to the other thing, and that you will lost control on your costs and resources and money, and yeah, you will bankrupt, broke, and everything will be not funny. But we here to discuss about this and where this story actually begin original. So not so far away in the spring this year, I have done two big researches. They had been done locally in the EPAM. So we have community, and we are doing here the technical meetups, researches, and talking about different technologies. And we have talked about the serverless Java. Was my presentation, and after it, there was a discussion with multiple people. We have talked about that the Java is not suitable for the serverless, right? So some people had shared their experiences, like saying, if you start project in the cloud and it's serverless model and you write in Java, you are in bad situation. Actually, you are losing a lot of money. You can choose any different language and it will be better. So some people shared, some person shared the information that they had rewrite everything in Go language and had decreased cost around 10,000 in a month, $10,000 in a month, and such stories. And we had discussed this topic a lot, and I had make a personal research about the serverless cost, and the mission of this talk and research which we are doing is analyze the impact of programming language choice on total serverless application cost and its performance. So we will discuss together two topics. First, we will talk about the cost of serverless, abstracting any programming language, how it built, how it can be increased, decreased, and from which parts it consists. I will share with you some analysis by consultants, by different big companies. And next, we will go back to the performance. We will talk about Java runtime. We will talk about custom runtime. In our situation, this is Graal VM. We have used native images, which are known as an opportunity to make Java much more faster in the cloud. And in the end, I want to make a community call, guys, to you. So let's begin. Some people say that I'm sometimes talking too long stories and like to start from the very, very beginning. But for me, I think it's crucial to understand the general aspects, the main ideas to proceed further. So when we are talking about serverless, actually about creation of new system, we are starting talking from the requirements, correct? We first will communicate with business, and actually business, not we, want to create some system which it needs. And business provide us some functional requirements that they want the system do this and something else. But to imply this system architecture, we need to know some non-functional requirements and quality attributes of the future systems. And before we go further, let's agree with you that we understand the constraints and the quality attributes which are provided to us by the serverless environments. So let's take a look at the constraints. So let's agree that serverless not fit your model if you need some long atomic workloads, which you cannot split in some parallel processes. If you struggle from cold start latencies, so you need very fast, immediate response. You're afraid of vendor locking. I know that right now exists a lot of open source on-premise solutions for serverless, but in the scope of this talk, we will talk only about the cloud providers. And if you, for some security reasons, don't want to move to the cloud, just because it's may be public, you may have some private data, there is some restrictions, regulators. So in this situation, serverless is not for you, and we agree on this. Next, let's discuss about NFRs. So, and quality attributes. Well, actually, what is quality attribute? Actually, any word which end with ability is fit here. So I have copied this list just from Wikipedia, just to show how it works. But let's better understand which quality attributes provided to us by the serverless model. So by serverless model, Mainly, we are talking about scalability, availability, maintainability, testability, and all other topics. Yeah, so scalability, saying that the serverless can scale in big moments. So you have, I don't know, 1,000 requests, and in few minutes you have millions, and you're scaling that you all time have working environment. If something goes wrong, you will have a new container with a function, and etc. So it's easy to test, it's easy to reuse, and that's actually how the serverless is sold. But which from these quality attributes sells serverless more than other? This affordability. When people talks about serverless, affordability is mentioned more than others because in ideal world, it should make your system inexpensive. So you're just paying for what you use, right? And this is actually the answer on the next question, why serverless sold as affordable. So this is pay-as-you-go model. So the idea that you don't have some server which running all the time, right? And you are paying only for the time when the code is executed. So this is some cost formula. I found it in some consultants research, consulting, very serious guys. But what I want to mention in this formula, when we are talking about cost of serverless, so how to understand it? It's very simple. So this is the cost of all requests, right? How much your code is executed. You should sum all of them. So to calculate the cost of all requests, we should calculate the cost of each single request and calculate them. With three important variables. So this is fixed cost per request. This is how cloud providers defend themselves from big amount, very small, cheap requests. So they protect themselves, so they never non-profitable. So to earn money on each request. And next, actually, two variables which you can change. So you can change duration of request in the serverless environment and cost for a single request, right? So we know that we can scale in and scale out the function. In the example, for example, we will talk mostly about the AWS Lambda as most well known. You can scale amount of memory or increase or decrease, and depend on this, function will work faster or slower and cost more or less. So when we are talking how to optimize this formula, right? So we want our serverless spend as less as possible. So answer is pretty obvious, right? So just reduce the amount of requests, execution time, and cost of single execution. Just decrease everything to a minimum and you will win. So simple enough, right? And I tried, okay, if it's true, let's find the most fast, less memory consuming environment and use it, right? I had done this pretty quick. Actually, I have found research in the medium and came across familiar people. This is Roma from the Orange stream, right? And Alexander, who had created big topic called AWS Lambda Beta 2021. So they had compared the different environments. So they have made 3 runs. They had created a similar system, which consists from the function and DynamoDB database and gateway, and they have call the function all the time. So there was 3 runs for each function and around 5,000 iterations. Each function have 200 megabytes of memory and compare them between each other. So this is a pyramid with results. So on the top you can see the Go language. It had been, it's a king. On the bottom you had seen Node.js, Java, Ruby, Python, C#, Rust, Graal native images. And so seems we know the answer and know how to hack the formula, right? And so we are taking this formula and putting here Go language, right? And so we just win, we are the kings. Sounds reasonable, right? But let's think more about this, right? When we are talking about serverless cost, I think we are looking too precise. I mean, we need to make picture a bit more wider, right? Because the cost of serverless application is not only cost of functions, right? Because when you build the serverless application, it will have a lot of infrastructure around it, right? And this infrastructure not always depend on the programming language, right? So let's right now zoom out the picture and take the whole look on what's going on. So when I came to this research, I had started to think, okay, I know that the Go is fastest, but how much I will spend on the other services? Is there some maybe projects which had shared this information, or companies which had said, okay, we had built a serverless system, it ran in a month and cost such amount of money. On such service, we spend such amount of money, on any other different. And I want to find the percentage and create maybe some average or mean value, to understand how much we actually can tune. Because if you will, for example, replace Java with some fastest and more efficient service, right? How much will be actually this change in the percentage? So serverless computing, yeah, as I said, need infrastructure around, and I was trying to find the percentage and find the big AWS cost calculator, which I will share with you, done by Xavier Lefebvre. And what this calculator provide to you? It have different application types. It have different load scenarios, which you can combine. It use most of standard AWS services. It built for the serverless, and you can compare them. So it had 4 application type. It had collaboration tool like Miro, Lucidchart, or something similar, a blog, e-commerce, chat, and have different load scenarios. So low mean that few users, medium, high, very high user amount is growing. So how the calculator looks like? If you take a look at this spreadsheet, it may look pretty hard from the first on the first look, but I have created such animation to help you understand. So here you can choose the traffic, amount of traffic, and type of this tool. You have different variables which you can modify or use predefined, and this will allow you to see the resulting cost for such abstract type of application. So right now, I propose, for example, take a look at, two most popular one. So we are working in EPAM. We are pretty familiar with e-commerce, right? There is a lot of e-commerce projects in EPAM. So medium e-commerce, what it will mean actually, right? Here will be around 2,000 unique sessions a day, some percent of authenticated users, some amount of assets which they are loading, how much pages they're visiting, and the cost for this small system will be around $70 in a month, right? And please take a look at these calculations and find the lambda in this list. And you can see that whole system cost is around $70, but the lambda is only $3, right? So when we will start adjusting, increasing the performance of lambda and tuning this, we will mostly affect this value, right? So when you are saying that you can decrease cost twice, for example, replacing Java with Go, it's not fully true, right? And let's take a look right now at the big, very high e-commerce. Very high e-commerce. What it mean? Around 1 million users. Yeah, much more assets, etc. And right now, such system costs much more. It costs around 50,000 a month. And let's again take a look at the Lambda. Lambda is taking only around $5,000, right? So this is only a 10% of all costs. As you see here, a lot of money spent on the cloud front, for example, for CDN, for authentication, for working, for orchestration of functions. So this stuff is not completely dependent on the programming language, right? So next, I have taken the percentages. I have used this calculator or use all predefined values to find the percentage of lambda for different scenarios, right? Here you can see the table. So I had dismissed the values for with low traffic and take only with medium and higher. And the average will be 15%. So in average, you will spend on the lambdas only 15% of all costs, right? So, okay, great. We had found this value, but yeah, this is around 1/6 of all costs. But I think this is also not everything, right? Because when we are talking about the serverless application and we are saying that it's affordable, we should understand that actually the infrastructure cost, it's not all the cost of application. Let's zoom out again and think about such thing. Name it TCO. I don't know, have you heard about it, but it's actually trendy abbreviation right now, which states for the total cost of ownership of the application. And total cost of ownership for application is calculated from three big topics, big pillars. Is first, this is cost to achieve, cost to run, which we had discussed a lot before in this presentation, right? So we have talked mostly about the infrastructure and cost to support, right? What is spent after the application had been developed, running in the production, yeah, first release, and next we need to support it. And if we will take a look at very simplified model of this TCO, we will see that this is very simplified model, but we will see that we have talked mostly about the operational branch, and we had completely not talked about the time to market and development, which might lead to unsuccess with much bigger chance than the operational, because in the operational branch everything is simple, right? You know how much you spend on the servers, networking, databases, storages. Cloud providers give you calculators, you enter in there is amount of values, you calculating everything and fine. But when there came the people factor, right? When you need to find the person who will develop this system, who will support it, it's much more crucial, and the chance that we will unsucceed here is much bigger. I want to show you some statistic. For example, this is a report from the site, from the big recruitment site in the Ukraine, Gini. This is average salaries and availability of candidates with senior level, right, in the Ukraine. So, and we can see that for Java, we have around 600 candidates with our average salary 4,000, and we had much less candidates who will work with Go, so 83 persons, with higher salary. So when you will need to find such candidate, you might spend much more. You can say, oh, we have write everything with Go, it works faster. We we decreased costs in total from 5%, and we had hired a lot of Go developers, and right now overspending on the recruitment and the salaries, etc. So this topic is very complicated and very complicated, and I'm not expert in the recruitment and all this stuff, but I have here such very general things that to hire a developer, the process that of hiring development is takes around 3 or 6 his month's salaries, right? To find a person, to recruit it, spend it on the technical interviews, on all this stuff. But I provide you the great analysis. I will add it to the comments from the three big companies, from the Deloitte Consulting. This is big consulting company BBVA. This is big bank holding from the Spain, which had made the research actually about this topic, and international data company. So they had analyzed the total cost of ownership for this serverless and provide very big analysis for this. So the topic is very sensitive, and you should understand that the programming language impacts not only the operational costs, but also the development costs. And there is very different percentages, how much you spend and where. So you cannot just say Java is better or why Go is more or less expensive. So the second part of this research is so actually the research done by us, we want to analyze the performance and the cost of the real system. So we have seen some mock testing for the systems, but we want to talk about some real life example, and I want to show you our small architecture on which we are working right now. Actually, I want to add that we are not the super experts. Research actually states for what we are learning something, doing this together, investigating, and asking others to join or share experience with us. And we are sharing our own experience. So we had choose for the serverless the data pipeline, because the data pipeline should use compute much more than other scenarios. For example, than e-commerce or than blog, right? So there should be much more time spent with lambdas. How the system, what actually the system doing? On some of my projects, I had worked with a system which are just transforming the files and distribute them. So in general, the idea was to make something like, with same idea that it's actually used in the world. So this is not just some our system we just used only by us. So it takes a huge JSON array. This is a huge file with size up to 1 gigabyte, and it can take multiple files in a moment, unlimited amount. And next, it should transform these files in the CSV. So the process of transformation from JSON to CSV, pretty standard operation, right? So there is how like one line of JSON. It contain the array. This array have a lot of objects, and we need to create from this object table structure, right? How we will achieve this? There will be 7 functions to do this. So initially, the user put file in the bucket in the AWS, and next function triggered by this and will initialize the processing. So this is some kind of very fast running function which don't do any job and only responsible, for gathering the request and sending a message to the queue. So it should respond very fast. The idea that we wanted from as attribute from this function to respond very fast. Yeah. Next function is orchestrate function. It's, if you guys had seen Saga pattern, it might look familiar to it. Actually, this function is responsible to throwing file from the one function to other in a sequence. So this function used most than others. So it's under heavy load, also should be efficient and responsiveness. So next function is completely different. This is the first initial function. It takes the input file. Input file is always archive. It should unpack this file. This function don't have a limitation in memory, so it have up to 3 gigabytes of memory in any variation, in Java variation, in Graal variation, to just be able to get the big file in the memory and split this file in chunks. So when this function gets the file in the memory, unpack it and split it in the chunks, all the chunks will be processed parallel by validate function. So with validate function, we want to emulate some kind of CPU intensive task that you need to take a JSON in the memory, right? Run according to the schema, validate everything, and next transform the valid file in the CSV. After that, everything also is done in the parallel, so there is a lot of messages. We should combine these chunks in one big file again, and also we want to do this in parallel, so will be a lot of messages, and we will upload this file partially using the feature of S3 bucket, like multi-part upload. So we are uploading the parts of the file from the different function instances and next combining them together and again putting back to the archive. So this is sample system. So it should emulate as function which should respond fast and function which doing some work. And what had we received in a result? So actually how we have tested. So for testing of lambdas, there is a tool which you can find in the AWS documentation. This is open source tool to test the Lambda performance. You can actually see here the two variables which we have discussed initially. So invocation time in milliseconds and cost in the dollars. So what have we know? And that if function doing a lot of CPU work just scale up, that was our initial things. And if it's doing some, have a lot of idle time, so we will just scale it out in the memory, and seems this should be the most efficient cost. But is it work? And is it work always? And the answer is actually, as always in the programming, it depends. So with this calculator, we have run function multiple times. This function, this feature, power tuning tool, this is a set of step functions. You just deploy them in the AWS with one click. And next, you can choose your function, provide the ARN for this function, and execute this state machine. It will try to run this function with all our available memory setups. And next, we'll build you a chart. I will show you these charts. And you can analyze which setup is better for you. So here we have compared the register file job function, and you can see here that, for example, Java function and Graal function have completely different amount of memory, and you may ask me why, and I will answer you that this is the most cheapest setup for each of functions. So you can see here that the most cheapest setup for Graal VM first work faster, consume less memory, and cost less. So if you will take a look at the chart, so this is how the chart look like, which the power tuning tool generate for you. You can find here that this is under the arrow the longest invocation time. So you can see that with minimal setup with 200 megabytes, we will run more than 100 milliseconds. Next, on the other side, in the most below, you can find the most fastest running setup for this function, right? So if you have 3 gigabyte for the function, it will run more the faster. But the most cheapest, actually first, the most expensive variation will be here. So you see this spike. This means that you will pay for each of execution of 2,800 function, like some amount of zeros and 9, right? And the most cheapest is actually will be this. So this is the most cheapest variation of this function. Each memory execution you can configure in this power tuning how much tests run. So I have set around, as I remember, of 50 or 50 executions to find this value. So actually value can differ a bit between runs, so better to do them multiple times. Yeah, and in from other side, we can see the function from Graal. You actually can see the difference here. First, because the function using the Graal native is not benefit in the invocation time. As you can see, with any different memory setup, the speed will be mostly the same. So this difference which you can see is just because this function, all what is doing is few networks calls. So I think this is because the latency is might different between the executions, but this function is not benefit from the increasing of memory at all. So the most cheapest setup is for 200 megabytes, right? So it will be from one side, maybe a bit longer than others, but not so much. But it's actually much more cheaper. And yeah, this is very simple function. Let's take a look on the orchestration function. It's absolutely the same as the previous in terms of work done. So this is only API calls for this function. So it's just calling the database and pasting messages in the queue. And same situation again. Graal outperform this function. And yeah, so the graph is pretty similar here. So the less memory we have, the more long is invocation time, more we spend we getting faster, but you can see here that on the some step, you will stop get the benefits from the increasing of the memory. So here somewhere, yeah, you can find that the cheapest execution is actually 500 megabytes. But if you want to fine tune it for speed, you can see that invocation time start to decrease somewhere in this step, and the line is mostly straight. So you are spending much more, but you don't get benefit in the speed, right? So for example, for this function, scaling to the minimum is not so optimal because it will run much more longer, will be expensive, more expensive than the other. Yeah, and the situation for Graal is pretty the same again. Graal don't get the beneficial from the increasing of the memory, so increasing of CPU speed. So the fastest, the cheapest will be the most smaller function. So you can scale up it to the 3 gigabytes, but it will not benefit in terms of performance. But next, the situation is changing. As you can see here, the most optimal setup for validate file part function was completely different. So here we can see that the memory consumed by the validate file part function for Graal had been much bigger and much more expensive than the Java function. You may ask me why this happened. Let me show you the chart. So you can see that for Java function, with increasing the memory amount, the invocation time also decreasing, right? And at some step, we can see that the cheapest is 500 megabytes as always, and always fine. But right now, for Graal, we don't see the picture as before. So we don't see the straight line, mostly the straight line, and that we don't get the benefits from the increasing of memory. So right now we start to getting this benefit. I will explain right now why. So you can see here that with same invocation cost, right? So you can see here this straight line of invocation cost, we will receive much lesser invocation time, right? So you will pay same as for 500 megabyte function, which will execute for 6 seconds, and you will pay mostly the same amount of money for half 1 gigabyte and a half function. So there will be same amount of money, but it will execute just 4 times faster. So again, this lead us to situation that we need to fine tune actually each function separately. There will be similar situation for transform file part function, mostly similar. The Java have lesser costs and work faster. We will talk about this, why this happened. And you again can see that the same situation, that for Graal we have Pareto when the invocation cost is same, but the invocation time is different. And pretty same situation for merge file part function. So I will skip a chart because they're pretty similar. So after we have found the most optimal configuration, we have tried to run this on some real system, and on our with some real data. So for example, we will take one and process one file with size of 500 megabytes, and this will lead us to such setup. So register file job function will be executed one time, orchestrate file job function will be executed 100 and half, and you can see different amount of executions of each other function. So you can see that validate, transform, and merge will all be executed 50 times. This is because we split 50 megabyte files in 51 chunks, right? So each chunk is 10 megabyte size to process them in parallel. And next we in the end combine them and pack in the archive. And the situation here is pretty interesting. First, you can see here that the unpack and pack archive function had owes in performance to Java. Even this was just one execution. So this had confused me a lot why this happens. But you can see that in any other situation, so this is the average duration for all function, the Graal outperforms. So right, it's run much more faster. If we will take a look at the cold starts, there is again Graal outperforms, but we see issues here with unpack and pack archive functions again. And this is the minimum duration. So this is warmed up instances, right? So you can see that the difference again pretty big here, but it's decreased a bit. So we can see that Java started to perform a bit better. If we will take a look at this same system, which run under bigger load, and we'll compare which system is perform better right now. So right now we can see different amount of execution. So we had multiply everything by 10. So there will be much more execution of orchestration, validate, and all other functions. So they will be able first warm up and scale. And let's compare this with stable spreadsheets. So for average duration, we can see first that Java wins in the merge file part function, right? So under bigger load, seems Java function had warmed up and outperformed Graal function. Also, you can check that the percentages in difference for validate and transformate function also decreased. In the previous run, it was around 80%. Right now, it decreased for 40%. You can see here that the register file job for Java is still running much slower. This is because the S3 bucket trigger is triggering multiple instances and all of them starting in the cold start. In difference with other functions which are triggered by SQS and they're not scaling so fast and have less amount of cold starts. So there is one instance which all time consume messages, and only after some time there is additional instance. But when you are triggered by S3 bucket, as I understand, they trigger multiple instances in one time. So when we have put to the bucket 10 files immediately, there was more cold starts for in general. And you can see here that for max duration, so for cold starts, yeah, Graal is better. But right now for min duration, you can see that the situation changed. For warmed system, so it's run 10 files, we can see that Java start outperform under Graal, right? So we can see that transformation and merge start running much faster in the Java. We can see that validation is pretty close to the Graal. We can see that orchestration also pretty close, so there is only 10% difference, actually 3 millisecond difference. So seems under the biggest scale, Java start performing better. So the execution of one file for Java, so we have for 10 files, and for Java, they had been processed for 260 seconds. For Graal, it had been processed for 180 seconds. So it seems Graal faster, right, in total. But is it expensive or cheaper? How, guys, you think? I will be actually interested to see this answer in the comments, and I will take a water. Which of system had been cheaper or more expensive? So actually, total execution of these functions for 100,000 files, if we will extrapolate previous cost, I understand that this is very approximate calculations, but the Graal VM will be more expensive right now. And this is, we have been confused with this a lot, because you may ask us how the code is differs. Actually, it's absolutely equal. So the code is the same. The Java functions are written in the plain Java. Graal functions are written with Micronaut, but the Micronaut is, we have used the hexagonal architecture. So the all code is under abstractions. So the difference only in the handler, right? So the code absolutely simple, and we start investigation. Actually, why the Graal more expensive? for us. What is the reason? What's going on? Because we had been thinking about completely different. This is the X-ray logs, for example, for pack archive function. And you can see here the 2 points. So first is get object. This is when the pack function downloading the file. And next is the put object. It's when it uploads the packed file back to the S3 bucket. And the space between these 2 points is actually the transformation of a file, actually the packing. That's how we think. And we start investigate this point, and only code which was between getting file from the bucket and uploading it to the bucket, this is this function. So all what was the difference, how we think, is packing file in zip archive. So as you see, nothing here which should work slower in the Graal. We have read a lot about which issues can be here. We had found that Graal have issues, for example, with array copy. Maybe this may impact, but it had been fixed in previous versions ago. So very hard to find information. But next we have done additional round of testing and found that actually the problem not in the file transformation. So packing is pretty similar, but we facing really strange issue with file downloading. For some reason, so this code is the same in the Graal function, same in the Java function. Downloading in the Graal function much longer. So it twice longer than in Java function. And we are still investigating this issue, and this is no clear reason for this. Maybe this is the issue with AWS SDK, because seems it's just working slower. So we had consulted with some people, and seems it's just works like now. But what I want, yeah, the answer is slow downwards. But what I want to mention here that let's get back to TCO. Let's imagine that we some guys which should develop the system to the customer, to the business right now, and we are trying to set up this Graal. So we are investigating. We have facing the issue, and we don't understand why, for example, downloading Graal running much longer with than in the Java function. And we're spending some time for this, right? And imagine that we are spending days which are paid from the customer to just find this issue. So maybe you will benefit much more if you will write everything in the most common and most shared language, and it will get you more profit than investigating and beta testing some other stuff. I'm still interested why that's happening. So we have been advised by some guys, by the people who work with Graal to try different properties during the compilation of native image, for example. And this is pretty exciting to work with native images because you recommended some properties and you're trying to Google them, and Google showing you blank page without without any results because it don't know anything. And okay, next there was um, some typo in the property. I had removed it and I had found some documents in the internet, but it's so not described, and you have no understanding what's going on, and you should figure everything by yourself with comparison with some other language where is everything works fine, right? So you will need to hire more experienced developers, right? Because we are getting back to SEO. You will need to, for example, to developing this system in the Java or Graal, you will need to hire more senior developers. Maybe they should be more experienced than me to find the answer to this solution, if it have the answer why it's happening, right? So is it really what you want in the production? So the research is ongoing, and what I want to make in the end, right now we are trying to rewrite this system in the different languages. So right now we have finished implementation in Java, in Micronaut with native images. Right now is going work to write this with Spring Native. Also, one person joined us to rewrite this with Quarkus. Guys joined to write this in the Python, Node.js, and we are planning to write this in the most languages to just make a funny, interesting research and compare everything with everything and just create these spreadsheets. And compare everything. So for us, it's pretty interesting. And if you are interested and you're from EPAM, you can contact me in the Teams. I will guide you how to join. We have big documentation, how the system work, how to deploy it, how to configure it. And yeah, so you can participate here. If you're not from EPAM, I think we will open source the code. I mean, right now it's hosted in the EPAM Git, but I think we will put our findings in the GitHub so everyone can join and contribute. And yeah, we want to create a comparison because as right now we understand that we cannot pick up one scenario and say that Go outperforms. We need full kind of comparison. So we need comparison of different scenarios and etc. And I think this the end. I have shared all the information which we have on the current stage, on the current step. Actually, was the initial step of our research. We just have developed prototypes in Java and native images and compared them. And right now attracting others to join us and contribute to this research. Or actually, if you are some Java champion, not from VPAM, from anywhere, or you have worked in Vigral or somewhere in Oracle, and you can explain us why the downloads take more in Vigral than in the Java, actually the same code. We will appreciate this a lot. Yeah, so this is everything from my side. I will be glad to hand over to Tatiana or Igor.
So actually, we have a lot of discussions below our speech. So basically, let me try to find the most interesting ones because we have kind of small amount of time to proceed. So the question: did you try Lambda Snap Start in your research? So have you considered it?
Sorry, what Lambda Snap?
Snap Start. This is kind of a new tool set for improving startup performance in AWS.
No, I have actually not heard about it yet. Yeah, not here, but I think I will take a look on this because I think no one had mentioned it during our research.
It's interesting. I guess we will proceed discussion in Discord after a couple of minutes maybe. And AWS is a group on Montenegro. If you are with us, you can join and tell more about this. I believe not only Mykyta and me did not heard about Snapstart. Join us in Discord.
So actually, I've shared links to our continuation of the Discord discussion, where I could try to sound all of your questions. So as I understand, we should give a stage to another speaker. Am I correct?
We still have maybe 10 minutes, and we can answer a couple of questions more here.
Yeah,
Okay.
fine for me.
So let's move on with the questions then. And one of the question was, so basically there was kind of discussion in chat, which led to the following question. What about the heterogeneity or homogeneousness of an application? Is it better to use less different languages and don't care about Lambda's cost? From your research results.
Yeah. I can answer only in general way because so if we're talking about hiring persons which will work with different languages, you should understand that someone and they will develop this system in the different languages. You understand that in this TCO someone should support it, and you will all the time need to find the persons who know all the languages which you had write. This is good to write, when the microservices begin. So some companies allow to write everything in language which you want, and people was just sitting and thinking, okay, which letter for programming language we had not used yet, and okay, A, let's choose something for A, and it's a mess. I think we should make profit for business, not tech for fun. I mean, we can make tech for fun in our projects, for example, in such research, and you can join us and we have fun here. But I think when we are talking about someone's money, I think better to, we'll have expertise with one technology, because, for example, if you have expertise in Java, right, you have not so good expertise in something else. So this is my overview, but it may differ if you have other experience.
Yep, actually, the worst case of choice of language which I saw sounded like it was a great opportunity to study a new language in production project. That's amazing. Yep, so I also totally agree that the choice of language should be a rather important point in general, while and all of the points which you've sounded during the presentation should be definitely considered. Yep, and basically a lot of feedback regarding the animation of your presentation. I think that it's worth to to mention this, that guys say that this is a great presentation, especially great animations. So actually, I think that the other questions mainly are about the comparison which you've shown, and for some guys, just an interesting point, some guys, a lot of guys basically also were very impressed by the fact that GraalVM showed such interesting results and unexpectedly worse results in comparison with traditional Java. So actually, I think the last question will be from my side, and all other interesting points which guys sounded, we will try to discuss in Discord. So basically, what are so you've already sounded some of the further plans of your project, of your initiative, but do you consider any further enhancement in terms of other serverless services, like for example AWS Fargate or something like that? Are there any area of enhancement in other AWS services for your investigation?
Yeah, so this research is done by people which are just joining and want to contribute, and we are pretty open. We are sharing our experience, and someone, we just not came in and saying that, hey, listen, you should write this in Quarkus to the end of month. No, completely anyone can came, and we just showing the system which exists, and you can compare it with anything what you want. Actually, we had not planned to compare with Fargate. Fargate is actually containerized solution, actually working with it in production. I know that you can run actually the container in the Lambda environment, not in the Fargate, but we had not tried this. Maybe it will be also interesting. So as I know, we had discussed with some new person which joined to us that it will be interesting to try this in the open source. I forgot. KubeOS, Knative technology to run serverless on premise and compare its performance, for example, with some existing solutions. How to deploy the cluster.
Thank you. So, guys, please feel free to join this interesting project and to contribute to it. Hopefully, this will help us to have the comprehensive view of how basically the overall serverless systems in AWS might work better and more optimized way in terms of cost as well.
Totally agree with you, and it's moreover, it's changing mindset. More of developers, not more, but in the very beginning, middles, seniors, starting talking about performance in terms of only Lambda, speed of running something, execution time, and so on. And here we thinking very on high level. We took a look not only on performance, but on the developers, on market, and all the things. So it's rather adult mindset, and this project help not only became more experienced in languages or lambdas, but more adult, let's say. Okay, and we did not highlighted that most of our viewers answered in correct way. So Java is cheaper. Mykyta asked, and we see that, our, for example, who was first? Hunar Letsko. Great. Very attentive and very fast answer. Thank you. And all others, of course, Ilya and Vladimir, all who answered in time. So guys, I guess we can switch in Discord and start preparation for another one talk that going after
Thanks,
this
everyone.
one. Yeah. So link.
Nice to hear everyone.
Mhm. Thank you, Tatiana. Thank you, Mykyta. It was great. It was great and very, very interesting. Colleagues, do not forget push like button on YouTube, and please do not forget to mark our talks or with comments or any your reaction, because it's very important for participants, for us, for speakers, how they did their job. I believe it's very interesting, not only for us and for you, and we see it in comments. So I guess some of you will join Discord and proceed discussion on Lambda and performance. And let me highlight what's next waiting for us in 15 minutes. And next topic on our Orange stream. I just remember for guys and girls who joined us not a long time ago, we have today conference and we have two sprints, purple one and orange one. Orange stream, you are here, and link in the description on purple stream, and topics that currently starting on their stream and on ours are, what do you think? Some of you, of course, used to read agenda and know about it, but I, of course, remind you. So on Orange stream in 15 minutes, we start very interesting topic about Azure functions and Java. Why interesting? Because as you maybe involved in Azure, for you it's normal. If you only in Java and AWS, perhaps you heard that Microsoft became more active in integration Java in their solutions. And our next speaker will tell more about how Java integrated in Azure. Is it good or not? It's good, and he going to share his own experience on this. So Mikhail Kotor will tell about this soon, and it's on Orange stream about clouds, and not about AWS but about Azure. And on the purple stream, very interesting topic. I want to see it, but of course I will take a look in the stream after our day, because it's very useful for all who are working with code. Jagger's cameos going to present unit test as a specification. This topic will help to understand how it's faster and better to prepare documentation. On my project, I working on big project. It's a CAM, and documentation must have. And any project who starts from on the scratch or startup in the very beginning may be missing something in documentation. But with the right tools, with the right approaches, you will not be able to miss something, and everything will be on the place in time. So this is two speech. This is to take talks waiting us on our stream and on purple stream. Please decide which one you want to watch and choose. And I remind again that in Discord just now, our Mykyta talking about AWS and performance, and also in Discord you can find some quizzes, and we will have a chance to win IntelliJ ID Ultimate license from JetBrains. It's not ours, it's from JetBrains. They are our sponsor, like PAM and all the community. So colleagues, let's take small rest in 5 minutes and maybe 3 minutes, and we'll return soon. So don't you can, I mean that you can switch, you can drink water or something like this, and we will meet you soon. So small. Okay. Ой, я был замьютан. Ну что, тогда, наверное, погнали. Hello, colleagues. Sorry. we are here. So small technical issue. Okay, colleagues. We are ready, and as I told earlier, this is next our talk again about clouds, about Azure, and of course Java. Let me introduce next speakers and moderator.
Hi guys.
Hello, hello, Andrei. Hello, Mike. Oh, so we are waiting for your presentation, of course, and your speech. And can you please few words about what we are waiting for?
Well, actually, I would speak about how I used Java functions on my project and my experience, what issues I faced, what was great, and what to do next with that information.
Okay, great. Oh. And Andrei, how are you?
Yeah, I'm fine. Personal experience is always very interesting topic because I have also some personal experience, and it goes like vice versa with your presentation and with previous presentation. Because when I was working with serverless, it was JavaScript, but it's a stop word for this presentation because we're talking about Java today.
Yeah. We most not only about Java, about clouds, and very interesting because most of our colleagues, me, we are working with AWS. I don't know why. I know why it's so popular. However, Azure not stay on the place and developing services and so on. And AWS market will. Growing, I mean, that Azure will be used more and more in the future. Why? Because Java inside, as I told earlier, usually when we're thinking about Microsoft, this is a .NET development, yeah? And maybe this year and maybe earlier, Microsoft began actively introduce Java in their services. So Java in Microsoft, wow. And of course, in Azure. I don't know how it's on current iteration. Mike will tell about this, what Java and Azure looks like now. However, in the future, it will be maybe more powerful. So,
If somebody knows, please type in comments. Is it possible to run Lambdas with Java on GCP platform? Because some time ago, I wasn't able to do that. I'm not sure about current time.
Interesting question. GCP and Lambdas.
On Java.
But what,
On Java.
Java and Lambdas. And what about Azure? We can?
Yeah, we can, but some issues, of course, about.
But some issues.
Yeah.
Yeah. But without issues, we don't have any chance to run something.
Yeah,
And
that's not like when everything is working, there is no there is nothing to speak about. But when something is not
Exactly.
working, there is a topic for presentation.
yeah.
That's great.
We know. Colleagues who work with us, tell us in comments what you are working with more, AWS, Azure, or did you had a chance to work with both, or you working only on Azure, and your minds about if you had a chance to work with both, or what is more convenient, more interesting, powerful for from your point of view. Write in comments because it's a very interesting topic for all of us.
And maybe
Okay.
somebody has experience with GCP.
GCP, we need to create a separate topic with GCP, I guess. In today's topics, we don't have, but in the future, we have to cover
Probably,
this. Okay, Mike, word to you. Let's move in Azure and Java.
Oh, okay, let's go. Yeah, first of all, we support Ukraine, and there is a fund that helps Ukrainian refugees, and there is a link, QR code. This money will be spent on what you can see on the pictures on the right side. And I would leave it maybe for a minute for guys who want to donate to have time to scan QR code. And after that, we could proceed. Yeah. Okay, I think let's go next. Well, once upon a time, I started to use Azure Functions with Java. And my suggestion was not to do that. And I would like to tell you why that happened, what I was facing, what happened, and actually my experience. Well, let's start with self-introduction. Maybe I would tell a bit about myself. I'm senior software engineer in EPAM, working as a team lead. My last project was based on Azure and Spring. Basically, everything there was connected about Azure, so we used most of the services, like Cosmos DB, Key Vaults, APIM, Event Hubs, and also we tried to use Azure Functions. We had them not that much in our team, but I introduced them into our team, and that was at the same time was a good experience and sometimes not the best one. Well, let's speak at first what is an Azure function. Actually, if you haven't been working with serverless, for you to understand, you just actually write some code in one function, and this code would be executed. Of course, there are several limitations, and let's start with them. The first one is stateless. You should understand that your function it's like some kind of a static function that doesn't have a context. So you're not able to store like some variables into local ones. And you should understand that. Well, also, one thing that everybody is speaking about is hold and cold start. I would speak about that a bit later, but for you to understand, hot start, it's when the function is working, and cold start when you need to start it to make it work. One of the main features why Azure why serverless and functions are really great solution is autoscaling. Just imagine you don't need to think about running your own servers. You just post some code and then it just starts working, and it scales in case you have high load, and it kills other machines in case you have nothing to do with that. This also makes a bit cheaper for you, and of course for person work, so you don't pay for developers to handle. Also, like, you can actually have some state, but for that you need a storage account. You basically connect the database to your function and you save all your states inside database. But that's like a bit more difficult, and that takes more of your time. And there are mainly, especially in Azure, there are mainly three ways of how to trigger a function. Three ways: HTTP, Event Hub, or Scheduler. HTTP means you expose your function to the worldwide or like inside your network, and somebody can hit it with a REST, or like usually with a REST by the REST event HTTP request. By Event Hub, you can receive a message and trigger your code execution after message, or by a scheduler, like once in a minute, for example, you send a notification, I don't know, something like that. Well, basically the difference between a cold start and a warm start. Hot start is basically cold start without preparation. So what is cold? Azure, like when you first hit your function, it doesn't like working. So Azure allocates a server, usually like a machine, like in Amazon is 2 machine. It deploys its own work on this machine. Then the function basically started to load into the memory, and then only your code runs. In the hot preparation, everything that is passed, and then only your code is running. Well, one thing like to mention that in Azure there are like a premium subscription tier. In that case, you don't need to think about cold start in several directions. It will be like at least one function always will be running. Well, especially to mention about versions. Now there are like 4 versions, but I found open statistics for version 1 and 2, and you can see that Java, it takes from 20 up to 30 seconds for cold start. For C# and for JavaScript, it's a bit smaller, but still it exists. We'll speak about that a bit more after scaling. So what I was trying to do with my Azure function, we had a task, and I needed to implement an OpenID Connect client. Basically, it's several API calls, basically OAuth2 plus user info endpoint, a custom one. So it is discovery, authorization, token, and user info. User info is a custom call with custom fields, so we decided not to use Octa because it was paid and we need it fast, so we did it ourselves. Actually, also it doesn't store any state. That's why it was an easy solution to do not to do a microservice, but to do just a function. And it should be exposed to internet because it should be available for everybody who uses this. Well, why I considered to use Azure function for that. First of all, it has different languages, as you can see on the presentation: Java, Node.js, C#, Python, Bash, but also to mention there are different versions. For Python, it's mostly like, I think, 3rd version, but for Java, they have 8 and 11. Unfortunately, no 17 yet. For Node.js, much more versions, and for C# also some versions. Some other developers from my team had experiences with AWS, so it was familiar for them how to use functions, because usually they're kind of the same. And I would speak a bit more about plugin support that has different ideas, like different code editors, and deployment from local to cloud. That's actually works. You can do it from one, like in 2 buttons, actually, like 2 clicks, and that's kind of easy. It could save budget. In my case, that was not the main point, but it was more about fast development. And also you can collect perfect metrics from the special service that gives you opportunity, and it's like really a lot, and you can easily like even connect to SSH. Yeah, that's actually like how the plugin looks in Visual Studio Code, and that's how it looks in IntelliJ IDEA. Actually, in IntelliJ IDEA, it's a limited version because, like, Azure prefers its own code editor, and they even announced Java support there. I'm not sure how they want to beat IntelliJ IDEA. I have no idea how that would happen ever, but they try. And yeah, so basically from here you open function app and just click start, like deploy, and that's basically it. Like refresh, and there is like a deploy button. Well, that's looks how the dashboard looks when you deploy your own function, and you can see the information about here. Like you can see all the app environments. You can connect to the SSH console, like SSH, or it's on a Windows machine. You can connect to Bash directly. And I think that's all about here. Well, what were disadvantages I found out? First of all, there were like several issues on local deployment. I was using Mac at the time, and it was Mac M1. And with that, when I was starting my local application, it was starting perfectly. Like, when you need to start the debug, you need to start like basically 2 processes. You need to start the function, you need to start the debugger itself, and you need to attach the debugger to your Java running function. You need to expose your port. So in my cases, it was starting the function. Then when I was stopping it, it wasn't stopping it. It was just stopping the debugger and not stopping the function. And when I was starting a new function, like it was starting a new function, but attaching the same debugger to the old function. So in my case, when I was rerunning the function, I just had several copies on functions, and I was not able to identify why I changed my code, but the behavior doesn't change. And that was not the best decision. Also, for me, in my case, like I was using this for OpenID Connect client. It was used for mobile. So for me, local was like kind of difficult to reproduce, and I wanted to use it in remote, like to deploy it, because I needed to click it from the mobile app. And in my case, it was no remote debug. There are some issues that there are 3rd version and 4th version. In 3rd version, there is no such function. And in 4th version there is, but it's only on Linux machine. But in our like DevOps is created a template for Windows machine, and that's finished to work. Also in 3rd version there was issues with custom logs. No self4g, no log4g, like no login, only the custom like Azure provided login. And yeah, at first I was surprised why I can't see any logs. Also, no editing in portal. For JavaScript, you can type your code directly into the browser and deploy it. It's not like really big thing like what to speak about, but it's like one of the things you want to have, because other languages have it and you can't understand why you don't have it. Secondly, for example, like they created the plugin for the IntelliJ IDEA, and they have like around 90% of functionality. And after that, you need to use, in case you want to use the left 10%, you need to use Visual Studio Code. For Java developers, I found it as a bug. Like we had a Gradle project in IntelliJ IDEA. You can easily build a Gradle project in Visual Studio Code. It's in preview mode. So we had like a kind of a custom paths for our project. I mean, the structure, we had like an app folder and IP folder. IP is like an auto-generated one. to make it OpenAP client. And in my case, Visual Studio Code was not able to build the code, to build and to recognize the Gradle project, and that's what's end for me. So it wasn't able to do it. Yeah, and remote debug is remote debug available only from Visual Studio Code. And there was one funny backend deployment. I would tell a bit later about it. Actually, it's here. How do you deploy basically? What is done? You don't like deploy jar. You build a zip file with a special plugin, and you basically upload the plugin, just like you can upload it manually or just upload it via button. No difference. In my case, it was just an error has occurred. That's all. The whole message, like nothing else. I was investigating that, I think, for like half a day, maybe a day, and I found out that it happens because the Java runtime logs the var file in case you used a previous function. So what I did, we had a template function. I uploaded into the function I created, and then I made the clone, like a fork basically from it, and edit my code. And when I did a new function, it was not able to be deployed. I mean, that's usually not the thing you usually do, but in case you find out that and you face it on your project, it might be an issue. So actually, like, deleting the function and recreating helped me. Yeah, well, to sum up, and I will speak about more like cold and start time a bit later. After that, like, there is a bonus little. And about like what to sum up, it's like really smooth deployment. I need almost zero DevOps work just to create a repository for me. It's really good for jobs and for stateless applications, and of course for notifications. Like, to send a message, notification is really not a difficult thing. And of course, guys, do not use it with Java. Not right now. And of course, there are alternatives. We could create a managed service. It was like a fully microservice with all the deployments. But imagine, for that, we need to create a pipeline to deploy it, write integration tests maybe, create unit tests, create all the templates, like allocate a special server, add it into the cluster, Kubernetes. That's like really a lot of work. And for DevOps, like, to expose it, we have like all our services in one cluster that is not exposed to internet by default. So in my case, I needed to use a PIM also, and that would take like lots of time. Third-party solutions, there is Okta, which makes most of my work in my case, but it's like, first of all, it's paid. And when you write a project for another customer, to approve a paid solution would take you months, because they need to allocate the budget, they need to sign up a contract, because you cannot use it like a free trial, because like for legal issues. Yeah, that's. And there is a bonus. Of course, there is like, oh yeah, just wait, not that fast. There is a bonus. You can run native images on Azure Functions. The idea that starting from Spring 3, Spring Native is like Spring Boot 3 version. Spring Boot Native is included inside the Azure, included into the Spring Boot. And you can easily build a Spring Native image and run it, and it will start really fast. But the one thing you need to remember about like the cold start, the idea here that even with a premium tier, when you have at least one instance running, just imagine, in case you have a high load, the images like to be deployed like a regular Java, you'll still need to wait for the cold start to be at least the third function to deploy. Just imagine you have one request per minute, and for example, like one instance can handle like, I don't know, 10 requests, for example, is a really difficult job, get time consuming. In your case, when you will have 15 requests in a minute, like in once, it will not be able to handle it, and it will start to recreate a new image. In that case, it will take you at least 20 seconds to wait, and the clients will have to wait. 5 clients will have to wait, and at least 20 seconds. In most cases, like, people usually have retries for 5, I think, seconds. So in your case, well, in case they have like 4 retries, that will work for you. In case they have 3 retries, they may fail, and your client will not be able to handle that. So I think you really need to think, and Spring Native might help here, but again, like Spring Native, at least for now, with all this like Graal VM, makes it like a bit difficult because you lose lots of Java features that you really want to use. Well, thank you. Thank you for listening. I'm open for questions and for discussions. I see several questions in the chat.
Yes. Yes, we have a question about Java cold start time. What was the implementation? Because our colleagues had a similar issue with Spring because it's very heavy dependency injection framework. And then when they switched to lightweight framework, issue was solved. What was your implementation?
Yeah, well, first of all, like when we're speaking about Spring, you might see that first of all, Spring by itself is not that fast framework. The idea that it's when you just build a new image, like a new project, it will start, as I remember, like at least on Mac, for 2-3 seconds. It will just start. In case you add a database connection for localhost, I think it's like already 6-7 seconds. In case you have like lots of bins, it start to work them and it's at additional time. In case you have, I don't know, security, for example, you need to get a token on a remote server, that will take like at least 2 more seconds. In case you have Kafka, that will take you around like, I don't know, 20 maybe seconds, because Kafka has like really lots of connections. How they do that? Connecting to Kafka like via Spring integration or Spring Cloud is like, I think, a pain. And well, you can do like lazy startup, so like not to load all the beans and just like call them, like, in case you will do a lazy startup, that at the same time that it will decrease your speed time, but when it will increase the first calling of the time. So in case it like really depends, it might be help, but I don't think that's the solution. I know, for example, you can use like a Quarkus for that. I think that's a better solution, maybe Micronaut, but actually I had like a negative experience working with Micronaut. For me, it was not the best solution. At the same time, maybe Google, how's called, Google Juice, I think, right?
Yes, you're right.
Yeah, it might help. It's like a lightweight dependency injection framework. I think that could work here. Yeah, I see.
If you take Micronaut or Quarkus, you will lose something like some Spring features like Spring data and something like that.
I remember like the idea of Spring Boot, that you write like as less configuration as possible and everything is auto-configured. In Micronaut, that doesn't work. That doesn't work like that. You need to configure everything yourself. And I remember I was connecting a database, a Hibernate basically, and to make the Spring Data GPA, some kind of it in Micronaut, that took me like, I don't know, like hundreds of lines in XML, configuring the policies and then creating configuration files. I mean, I would not recommend that. I mean, maybe it's like in case you need that fast start time, maybe it's an option, but not my case. Yeah.
Okay. Next question. Do you know, is Azure Functions the only service which works not so well with Java?
Well, I think the best version there is, I would actually call, I think it's like C# because it's like natively for Azure, and I think JavaScript because it's just like really easy to do it. I mean, compiled languages is a bit difficult to work with in serverless, and interpreted languages, I think it's a bit easier, like Python at the same time. But Python is like at the same time not that fast as it could be. And so it's also an option. I saw there is a version of Bash. I cannot really imagine how that's possible. I mean, I think some guys could do that, like in Bash language, like do IP calls. I don't know, connection to database. But I think that they made it just for fun. Like we could add a label that nobody else added. I think that the version interesting. Is it possible like to run a bash on a Linux machine just for fun? No? Yeah. So I think there are, of course, there are other languages that doesn't really work well with Java. I think that definitely.
Question is about another Azure services that doesn't work with Java
services.
really well. Yes, maybe you know.
Well, services. Oh. But like other services, like are mostly like you don't. I mean, you don't really put your service like code inside these services. Like for example, even Hub is like a working service for Kafka. Like message bus, you publish a message, you don't write your code there like directly. Like EC2 doesn't really like. I mean, Kubernetes, like you use your Docker images, it doesn't really depends which language you use there. I'm not sure. Like I remember in Google Cloud there is App Engine that is able to run applications directly. Maybe there is something like something similar in Azure. I'm not really sure. Haven't been working with that. Yeah, maybe that would work, but not sure. I don't think that there are like services that really connected to Java. Yeah, actually. Yeah, actually,
if you take something like EC2, you will have simple virtual machine and that's it.
Yeah, actually, I know. Like with Java, we had like a kind of an issue. We used Serverless bus, not Serverless bus, even hubs, like it's for Kafka, and there were like different serializers. And half of our project was using one serializer, and half of project was using another, a new one serializer, like kind of a default one. And because of legacy, they built the previous serializer, and some messages were not able to be deserialized back. And it was a situation that half of the queues were working on one serializer, and half of the queues were working on another serializer. And that's because previously they didn't include like a default serializer into the library, like a connector. And that was fun. Like actually, you sent a message and then you realize that it's not able to be read. So yeah, but they actually improving, and now it's fixed. Yeah. And I see there is the last question, right?
Probably yes. I'm pretty sure you know such popular solution how to solve cold start issue is to implement something like continuous warm up, some scheduler that will warm up your Lambda function. Inside Lambda function, you will have some kind of if it's real call, will invoke this function. If it's warm up, will just return zero, something like that. And do you think, your opinion, is it truly serverless or something goes wrong?
Well, first of all, like in case you want to have this, you can write your own function that will work on scheduler and click other functions. That's like self-automation, like machines already starting working without people, like communicating, like just to make sure it works. Again, like in Azure, there is premium tier. At least one machine, at least like one function will be always alive. But that doesn't solve the issue of a cold start in case you have a really huge load. Because one function will serve, but for scaling, you will still need to wait a cold start for scaling. Because like when you want to scale, you have to wait a cold start. So like continuously warming up, like just use a premium tier, that will work. But I don't really think that's the thing you need to do yourself. At least, I mean, it might save you some of your work. But again, in Azure, there is no exact definition how much time you need to, like, the function can die like in 30 seconds or can die in a minute. There is no predefined set of like limit of time that you really need to wait for that. So in case you make a scheduler for 10 seconds for each function in your project, yeah, that might be working, but use premium time that. But I would really suggest to decrease the cold start time as much as possible, at least in your application. And in that case, it will solve most of the issues. And asking your Sam, is it like a real serverless? I think still yes, because in that case you more think not about infrastructure, but you think more about code, and it really helps. I think it really helps solving business issues, business like problems, and like you don't really think about much about infrastructure. Like for microservices, you need like 3 DevOps. For Azure functions, you need like half of DevOps to manage that.
We have one more question. Do you see, and how do you see the future of Java in Azure in general?
Well, first of all, like now they introduced like Azure. Microsoft basically introduced that they are going like to implement full Java support in Visual Studio Code. First of all, like Visual Studio Code is a free editor, but I don't really think that Java developers will switch to Visual Studio Code. At least for me, I don't really like it. I mean, I tried it myself. It's really fast. It's faster than IntelliJ IDEA itself. But at the same time, I mean, the UI is completely different. The idea of plugins is different. You need to install everything yourself. And for me, as a user that was not really a fan of like Visual Studio Code, I was not able like to understand even how to start it like Java function there, because it was not that obvious. In IntelliJ IDEA, in case you open it, it's like more complex, like much more complex. It's like, like a really complex UI that you open and you see lots of functions there, like what you can do, like a lot of functionality. In general, I think in Azure, like they will support Java as much as possible, because right now for development, you don't really need Visual Studio Code. Like in case you don't use Lambdas, like everything else works fine. We have like around like 40 microservices there running with like different subscriptions, and everything works fine. Especially like now you build like everything in Docker, most likely like your application will run in Docker, and it doesn't really mean for you like on which service you run it, because any will support. For example, Azure provides its own like images for Java, which you don't need to pay, because in case you use Oracle, you need to pay like $25 per each machine you're running your Java JVM running. With Azure, they provide your own like image, and you don't need to pay for that, and you can use it for free, like inside the Azure, of course. The same with Amazon. I don't remember how it's in Azure, but in Amazon it's like AWS Caretta, I think, or Amazon Caretta.
Yes.
The same one exists for Azure one. I think they will add like more connectors and improve them. They do that like every release. With Java like function, they already added, like there are 4 versions. In 4th, they added the login framework, the custom one. They added the support of remote debugging. I think they like really improving, but of course that will take time. Like for any new technologies, you need to feel all that pain before really using it. And when everybody will use it, like they will be, once I think they can be the leaders of the market.
Exactly, you're right.
So I've decided to join to your discussion, our discussion, because we're very interesting. And one of our J talks, we conducting J talks periodically inside our company. We already discussed this Microsoft decision to integrate Java and support frameworks inside Microsoft IDEA. And one of the interesting things here, that all integrated things here are, sorry, it's my Java dog with me. His name Ales. So our idea was that Microsoft purpose is free of charge, yeah, and IDEA integrated payable plugins inside. And here we see that it's possible that Microsoft will win this battle, and Java developers will start to use Microsoft IDEA. So what do you think? Is it possible in future? Because so far I see that we don't. We
Well,
don't
I think for them it would be easier to buy IntelliJ IDEA, in my opinion. Only in that case, I would start using Microsoft for development, local, at least right now. Well, I think Microsoft have enough money to do it. Like, secondly, like for C# guy, that might be a bit not that nice to listen, but like in case people are not starting to use C#, like we will integrate Java and they will start using us. In that case, like there is lots of codes running in Java, and it's easier to integrate it into Azure than to switch to the language, because like integrate cloud is a bit easier than like to switch the whole application.
Yeah. And guys, colleagues who are watching us, I remind that you have a chance to win a free license for IDEA. If you're not using Microsoft IDEA, you have a chance to use Ultimate IDEA from JetBrains. So it's all things in Discord, and somebody going
Actually,
to win.
there is like one more question from Smart TV, I think. Smart TV.
Yeah, Andrei, please read the question.
Which one? 1 second.
I can read it myself. Like,
Okay.
Yes, sure. If you see.
deploy using Docker images, containers, and you will avoid all the problems you had with the deployment, and will enjoy additional features like function container customization. Yes
It means
and no.
not to use default one, but create your custom container.
The idea that like to get away from language. At the same time, that will work. I mean, that's a good idea, but at the same time, like for remote debugging, how do you imagine that? You need to open a special port, like you need to open like 5005 port again, for example, for Java development. And in case you go like with the control, in case you do that, like what is the difference like to deploy Docker image on Kubernetes cluster than on Azure function? Just auto-scaling, but you can put like auto-scaling in I don't remember, like in AWS there is a special service that handles this. You put a Docker image and that I don't remember the name. Guys, can you... Pardon?
Fargate one. Fargate.
Yeah, Fargate. Like you put in Docker image and it's do the same like as you mentioned here. The idea of a function that you write your code, you basically put your code inside the function and you execute it. In case you want to do the same with the Docker, just use Fargate. You don't need like the functions. I think Azure has something similar. I'm sure that Google Cloud has it, definitely. GCP, I don't remember. I think Google email, no.
Google uses Kubernetes for these purposes, usually.
Yeah, but I think there is an additional service, like just for one Docker image, it could be working there.
I do not remember. Yeah, because it's some distinction between Kubernetes and Fargate. It's a bit different. Fargate is really serverless, but Kubernetes is over some physical machines.
Yeah, but like all serverless is over physical machine. I mean, you still have no idea
how much is hidden.
Yeah, it's like how much you need like to dig to get into the machine itself. But I mean, when you do the same with Docker, that just goes a bit away from Java functions, like, or at least from function. Yeah.
Okay, so we don't see any more questions so far. Colleagues, maybe somebody of us want to ask something else, not related to exact topic, something about Azure. And from my side, for Andrei, maybe question: did you had a chance to work with Azure? Can you highlight the most powerful things from Azure?
I really adore Azure DevOps because it combines both Wiki, Confluence, CI/CD at the same time in one place. This is my favorite service from Azure.
Yeah, actually, I liked it also because we had like from my experience, it's like, first of all, it's like really easy to find the pipelines and configure them by default. And secondly, there is another way. We were running like custom, like EPAM custom test cases, and they were integrated with Azure somehow. So like you open in the pipeline, you open the link and it's open in Azure, like the test result, basically some kind of Allure.
Exactly. And it's
Yeah,
really
so
awesome.
they really have good integrations. And of course, like infrastructure as a code, like fully supported.
Yeah, because an old approach, when you have Jenkins, when you have performance tests, in another way, you have separate Confluence, separate Wiki, separate Git,
Grafana.
Grafana. How to integrate it in between somehow? You need to open probably some ports, permissions, security, and it's terrible.
Yeah, but
Everything
Yeah,
is in
you
one
also
place.
need to mention like login inside the Azure is not the bad thing.
why?
Well,
Why?
I mean, login, like not login like log in, but like login framework, like getting the logs, because they have like their special services, like how to read the logs, and you need to learn their like custom SQL language. No, not SQL, but like custom language, like some kind of like in Kibana to get the logs. And like that's not the bad thing, because
It's
sometimes you're not
interesting.
sure where to look
And
at them.
sorry, can you please give more details why it's not good? Because logs, it's our helper to find some issue in the production, for example. And if Azure is not good with logging, wow.
No, that depends like what you define by good. Like in my experience, like when you create like, for example, for microservice, you create like an application, then you connect like how it's called, let me remember, I think app inside application that takes all the logs and aggregates itself. At first, you need to understand that it aggregates the logs of the whole cluster. Then you need to filter these logs by your name of your service, like microservice, and then you get in all the logs from all the services. So in case it will be in production, you will have like as much machines as you have, the same amount of logs then you will have. And they have like their own custom of language. Like you can get into it and you can learn it, but why you're not able just like to get the grabs from directly from one machine easily? I mean, it's possible from the Kubernetes cluster, but not that easily from the UI. And that's not, I mean, they have like several like buttons with the word log, and you need to know directly in which one to click. Because when a new person comes to the team, he see like 5 buttons where to click on the logs, and this one doesn't work. You need to go to App Insights and click in from the drop down where they have like custom login, they have logs, they have activity log, and there is something else, and you need to choose the right one. That's not
Wow.
the obvious.
So it's time consuming to find what happens, the correct log, and sometimes you're mixing up because in production you have
and you need
dozens
to
of
remember that sometimes like this login works in a queue. If a queue is stacked, and for example you don't have enough space, like your subscription, for example, have 50 gigabytes of logs, so they will save only like 50 gigabytes, and that doesn't have like any meaning that somebody will overwrite your logs and your service have the logs.
Phew.
It's like shared 50 gigabytes.
And here maybe some tricks you have to be more to make this process convenient for you.
Well,
How you
I was
do it?
connecting directly to kubectl cluster and reading the logs from a pod.
Oh, so
From
old.
old way
Directly.
works perfectly for me.
That's
Okay, so
great. If you have the success.
Well,
so we have a lot of tools, but we like to go directly in machine and read log from the pod. Guys watching us, write in comments, what do you think about reading logs from a machine directly without using...
To admit, Azure provides like a great way, like you can filter the logs by error code, for example. they have like in a PIM level, like a PIM is basically a PIM management way. So like all the requests go to a PIM and then to your machines. They have like really good login system there, like the same issues, but you can filter by the status code, you can filter by the URL, you can filter by param request, by the arrow codes. You can, I think, even filter by the time, so you can like get the direction, how many times of the calls get, like all the analytics basically, and that was the good thing there.
Oh, I have one more question. How did you expose your functions? Was it
By default,
direct call or some load balancer?
yeah, by default it's export itself, but in my case we need to do it through a PIM level.
Okay. I got it.
You basically create open API file and upload it to a PIM and put the base URL to your function.
Yeah. We saw a response how to improve functions performance in Azure.
Google
Guys
Dagger,
switched
yeah.
to Google Dagger, yes, and it was a good one.
It's like I think it's like the same as, not the same, but like kind of similar to Google Juice. I
If
haven't
it's-
been using that, but that's just my suggestion.
Yeah, but if this is the same as Google Juice, JaCoV framework, maybe it's more performable because of lightweight, but you will need to implement a lot of logic you may need. So depends on situation to use or not to use. Google
And when you
Dagger.
implement it, it becomes the same.
Yeah, I want to implement, but you will spend time, nervous, and you still will not thought about the next generation of programmers. Either they are ready to drill in fast in new technology for them and understand new, like let's say, framework, because you're starting to implement new framework from the scratch. It's interesting for you, maybe that, yeah, but for next generation of developers, they will need to think in your way, to understand your mindset. And again, about documentation, it's our next topic here. But how to document all the things properly? Does Azure provide some tools for documentation, from code maybe to Confluence, to do this in easy way?
Well, a PIM, like one of the things that provide that, like you upload the OpenAP files, and OpenAP file is also like a documentation, kind of it.
Mm-hmm.
So you can easily export all the endpoints you have, and you'll have like kind of self-documentation. Not sure of anything else. I think there is like, yeah, well, documentation is basically on Azure not my best, not my strongest skill there. I haven't written there any documentation. Maybe there is some. Like, is comments to sections, is it connected? Logs?
Developers usually hate documentation. Developers like to code.
Yeah, totally agree. And the same for me when I'm writing the code and I need documentation. Oh, it's a time-consuming thing. But when you thinking about project as manager, maybe as architect, yeah, without documentation, you need to debug to understand code, and it's again time-consuming. So it's a craft to provide correct
Exactly.
and simple doc. And sometimes when developer reading documentation, it's not clear enough what he wrote about in this text. I don't understand. And you in this need not only put text, but draw diagrams. And this is, of course, art. Okay, colleagues, I don't see...
We can,
I see one more question.
One more question, yeah.
Yeah,
Okay, please.
let's answer the last question and we'll move to Discord. Question is,
Okay.
we have a problem with call start in Java when we need to create some like database connection or Kafka connections. Is it better to use C# or JS? I suppose it's really Holyvar question. And we can start and move to Discord to discuss.
Yeah, let's go there. Thanks, guys. Thanks. Bye.
Okay, colleagues, the links to Discord you have in the comments, in the description of this video. Andrei, I guess you can join Discord too with Mike
Yes,
and
yes.
proceed there. So, what do you think about Azure, your minds now after discussion with Mike?
We need to wait with Java on Azure. I'm pretty sure on that. But it's a growing technology, and we can consider it in a year to see how it's going. That's my
Yeah.
opinion.
Maybe year is a happy case, I guess maybe 2 or maybe 5, because it's rather large period for implementing new technology in their ecosystem, yeah, and new processes, and they need to influence on us, I mean engineers, to take a look on them. So yeah, but world changing and Azure trying to change something. It's changes all time is good.
Anyway, it really depends on the situation what you have. If you have some tricky case when Azure gives you a big discount and in your company you have only Java developers and you need to save some costs for Kubernetes, yes, Azure Function is a rather good choice even right now. If you do not have some strict performance requirements, it depends.
Yeah.
It's the favorite answer. It depends.
It depends, but it's true because are we talking about enterprise and big with I don't know 10 years of history, or something new like startups that should be scalable in the future or not?
For
A lot
startups,
of
it's a
things.
really good thing.
Yeah, because they are free to use any kind of technology stack, and of course, it saves their costs. The most important thing for any startup or for any project, costs.
Exactly.
Okay, okay, we can move on another, and I will highlight. Okay, our speech is done at 2 o'clock, or 2 o'clock by Montenegrin. In half of hour, I mean that we are going to start new tech talk, and this is again will be regarding documentation. We highlighted this topic now, and next our speaker, this is Peter Verhas, will told us about documentation as a code. So this will happen in half of hour. And now, if you want to proceed with speakers, you can switch on purple stream because this stream still on the air, and unit tests as a specification discussing there. So colleagues, if you want to proceed, you can switch. And we will return in half of hour here. Just want to remind you that you can participate in our victorines and quizzes and win some license for JetBrains, or take a meal because it's a half of a day. And on purple stream in half of hour on our stream, I remind you about Peter told you about, but on purple stream you can meet Karen Alexandra. She will tell you about monads. Very interesting, and she's a star. She's a super. So it's a hard choice, but we need to choose which talk to watch. Okay, so far from us, that's all. We're taking a break for 25 minutes, but not 25, but about 20. So see you soon. See you later.
Bye.
I'm muting. I was here and listened this soundtrack. It's so relaxed. I don't know who wrote this, but it's cool. So, hello again, colleagues. Who are watching now, uh, who just switched on YouTube or connected to us, I want to remind. My name is Igor Urbanovich. I'm from EPAM, engineering manager, and I am one of the co-drivers from modern Java community, MGC. You can find our links in the description. Join our YouTube channel. We're producing a lot of content, useful and interesting for engineers, and not only. And I want to ask you who are watching us now, share link on our stream with your colleagues. Because somebody skip it, forgot, or don't know about us, and with your help, you can join and learn something, or get inspired, or take minds in the right way. Why? Because our next topic regarding documentation. We discussed on our speech that this is sometimes boring thing when developer needs to provide some documentation. But of course, developers and engineers know this challenge and provide some solutions. And our next speaker, Peter Verhas, lead software engineer from EPAM, will tell us a best practice and another way how to do this. I want to introduce Peter. So come on.
Hello everybody.
Hi,
My name
Peter.
is Peter Verhas. I work for IPAM Switzerland for like 10 years. Before that, I was working for IPAM Hungary and I relocated. And today I will talk about how to write documentation. I wouldn't say the easy way, but a little bit easier than we usually do. Okay.
Yes, and I want to introduce moderator. Hi, Alex. Nice
Hello,
dog.
colleagues. Yeah, hello, colleagues. We have here internal chat for the work team, and I was asked, why shouldn't we engage people to join? So I suppose it's a good way of engaging people to join, just to take a look, just to let them look into our pets. So I see also here you have a fantastic cat. Peter, do you have some pet at home?
Yeah, I have a Doberman. I have a
Oh,
beagle,
Wow.
so 2 dogs, and I also
Wow.
have a cat.
yeah.
But for the sake of the presentation, I lock them out from my working room because if they are nagging me, then I cannot present really. Especially the cat always wants to come up to my lap, and then the cat swirling around here wouldn't help too much about focusing on some serious topic like documentation.
Yes,
Yeah.
the topic very, very important. And Peter, what do you think? Why it's serious topic? Why we
Because
need to improve this?
because it's boring for most of the developers. And I'm a unique person in this sense because I like to write documentation, but it's my perversion. I'm different. I know that. But being different also was leading and guiding me towards that I wrote books. And that's an enormous amount of documentation and writing a lot of text about Java projects. It was published by Pact. And also I created a tool in the last 28 years since I realized that documentation writing is boring. The tool I will talk about today was started in 1996. Actually, the very first version I created in Perl. Somebody may even remember that language. It doesn't really exist today. It still exists, but it's not really heavily used. And the version I will show today is a much more developed version, and it's written in Java, and it can be used to document Java project, but any other projects as well. Not only Java, it can be used for many other different things. I am going to renew my blogs, which I was not writing for a while, and I will use this tool to maintain the articles. I also use this tool not only for documentation, but also for as a templating tool for code generation in the Java GSI project, which is a Java code generation tool. And so I think it's serious because if you don't have a good documentation, then nobody will use your code unless they are very much forced, but then they will suffer. And you have to write the documentation. And then my opinion is that we should make it as easy as possible. And we should use all the technical tools that we have instead of wasting human resources.
Agree, totally agree. So we can start. And one more highlight that Peter, you told that you wrote books, you're writing you in blogs. So can we share your links maybe in chat, on Discord, or on description?
Yes, of course. Yes. I will share it with you, and then okay, just a moment, and it's very easy.
Yeah, we can later share, so it's it will be available. Okay, our colleagues who are watching us, I just want to remind you that you can write your comments, you can write your questions in comments under video on via community platform on Discord, and Alex will be able to read, and Peter after this presentation will answer. So watch attentively and write comments and questions. We are waiting. So Peter, let's start. Thank you.
How much time do I have?
About 45, 15 minutes.
45, 50 minutes. That's great.
Yeah.
I love it. And I also see the clock. So, okay, let's start. So write the documentation and the document as a code. As we discussed before we started this presentation, that the second largest problem with the documentation is that the documents get outdated, and writing documents is really boring. And yes, this is the very first problem, that documents must be written. You cannot avoid that. It's like a fact of life, like tax and death and writing documentation. These are the certain things. And there is a movement in the community, and this is not my idea. It's a very wide. There are conferences all over the world about doc as a code. Write the docs.org. You can see there the definition of what is really docs as a code, and they promote that we should write documentation like if it was code, the same way, and it already kind of makes writing documentation a little bit easier for the developers. But I propose a little bit more tools to ease the writing of the documentation, or maybe not to ease the writing, but to ease the maintenance of the documentation. So at very first, I will talk a little bit about what is doc as code, what it really means. And only for those who have never heard about it, I won't go into the details. And afterwards, I will explain a little bit how it can be extended or amended and how we can use some extra tools for that. And then the major part of this presentation will be a hand-on demonstration of the tool. I will use it in front of you. I will edit a document, and then you will see how this document will come into form using this tool. So what is document as code? So first of all, documentation is originally a different aspect than writing code. And usually, because of that, it's a different discipline. It's a different trade. It's not done by developers. It's done by tech writers. And it needs a little bit different skills. Of course, there can be some developers who also have the tech writer skills. But generally, these are two almost distinct principles. But tech writers, even though they are not programmers, that still, it's in their names, they are tech writers. So they are technical people. They understand the technology, and they can use technical tools. And this is an enabler factor for document as a code. The technical tools can be used. So it's not just like that, oh, I cannot work with anything else, only Word documentation. There are people like that, but they are not tech writers. Tech writers can use different technical tools like ASCII-Doc or Git or markup languages and other things. When the software evolves and the new documentation has to be created for the new release, then the documentation also has to evolve. And the problem is that when there are problems in the document, then these have to be discovered. And many times we can only discover it only during review. So we don't have things like unit tests for the documentation, but it would be great to have things like unit tests and have continuous integration for the documents like we have for the unit test, for the code. And there is a big difference is that the documentation is redundant by its nature. So many times when I have a code which is repeated at a lot of places in my code, then I say, okay, this code is used at many different places, almost the same. So I move it into a different method or different class or whatever, and at different other places, I am only referring to it and I'm invoking the code that I was refactoring. But when I have a documentation and I am documenting, let's say, configuration parameters, and by default, I set all the default value, all the Boolean configuration parameters to false by default. And then I have to document it. But it may not be really good for the reader to say that, just remember that all the Boolean configuration is false by default, because a reader may not read that chapter at the start. He is or she is interested in only this specific configuration and reads the documentation of the configuration here. So it has to be here that this configuration flag sets this and that. If it's true, it's this. If that's false, it's that. And by default, it's false. And if I change the default from false to true for whatever reason, I have to change it at every different location. I cannot do the same as I do, or can I? I will show actually the tool that with which you can do that. But in the documentation, you just cannot write that. And by the default value is, and turn to the page here and there, and it will be written there. Because just for the single value of by default is false, the user shouldn't be made to go there. It's a lot of work reading, and the documentation that way is unreadable. So the documentation has to be redundant because the reader who is reading it is redundant. It's like code inlining for the processor. When we are inlining a method, it will be copied into the machine code. And when we say don't repeat yourself as a principle, it doesn't mean that you shouldn't repeat yourself in the compiled machine code, in the binary. It can be can include repeated code. If that's the optimal, you should not repeat yourself in your source code. But then if we have a source code for the documentation, we perhaps may do the same. And doc as code tries to eliminate these bugs because it says that let's treat your documentation as a code. So what kind of bugs can we have? We can have language, grammar, and style bugs. And I cannot really help too much. There are tools for that, but these are something which are really difficult to automate, to fix. And there are problems with the consistency of the documentation. When the documentation is lagging behind the features of the system that we are documenting, or I'm changing some part of the documentation, but I'm not changing the other parts. And if I look at the previous example, I changed the default value for the Boolean configuration parameters from false to true, and I change it in the main chapter saying that the default is true for all the parameters, and I forget to change it at some place, and then it says the default is false, and then which one is right then? They are contradicting to each other, and this is a documentation bug. So how can we address these issues? Well, language, grammar, and style. There are some personal productivity tools like Grammarly, which I like, and I use it. And there are some automated tools for checking. But the major thing is review and regime. So there should be a process how we are writing document, who is reviewing it, what checks should be done, who should approve the documentation, and things like that to reach a certain quality. Now we have the feature log. When there is a new feature and information in the source code that we are documenting, what we can do really here is that we fetch the information from the source code automatically. So actually, when I say that the default value is false, I don't write there false. I write there something that will trigger during the document compilation, and which creates the final documentation from the document source code, will somehow fetch the default value from the source code and write it there into the final documentation. So fetch everything from the source code, which is possible to fetch from the source code. The other possibility is to doc signal the documentation and the code and automate the update of the documentation, or at least make warnings and failures like unit tests for the documentation. So I can say that I can calculate the checksum of a file which implements a certain feature, and in the documentation where I am talking about this specific feature, I write some things there which will include the checksum of the file. And if this checksum is different, then the file has changed, and then my documentation is outdated, and the documentation compilation process will fail and give me an error to change this checksum and obviously update the documentation, because the checksum difference is only a signal that something has changed. If the feature changed, probably, not necessarily, but probably, the documentation of the feature should also be changed. And there is another possibility to avoid or minimize feature lag, is to move some part of the documentation into the source code. I do it many times. And again, my example is the configuration parameters. These configuration parameters are usually listed in the source code at one place, one after the other. If I insert a new configuration parameter, I modify the source code, and I am debugging it, and I am doing whatever. And then I forget that at somewhere, I don't know where, but somewhere in the documentation, there should be a place where I should document this new configuration parameter that I was inserting. Or I delete one, and then I have to delete it from there. And with this tool, what I can do is that I write a few lines about the configuration parameters, because this usually, the documentation for one single configuration parameter is not too long. So I have a few lines in comments, which is in the format of the documentation, which is usually ASCII-doc. And the documentation automatically fetches this comment, removes the star characters, whatever in front of it, and inserts into the final document as the part of the documentation. And the third one, when the document becomes inconsistent, so at one place is different than at the other place, is that, well, I can define variables into the documentation and I can use them, or I can define kind of methods, or let's say it's called macros in the documentation. And there are repeated text, then, well, in the documentation, we should have repeated text. There is copy paste, but we shouldn't do it manually. We have to automate it. And the tool has to copy paste for me from one place to every place where I am using it. So this good old doc as a code is the existing one, and the new approach that I am promoting, and I will give an example with a tool, is what can be done with this extra step forward towards doc as a code. So what is the tool? The tool is a very simple in principle, very simple tool. It's called Jamal because it's written in Java, and it's Java macro language. 28 years ago, it was just another macro language, but that's not a good name because since then it evolved a lot, and it's a very specific and outstanding tool. And it does nothing else but it reads an input text, processes the macros which are in the input text, and creates an output text. So converts one file to another. Simple, is it? And where is the power in this? Well, actually, the power is not in the idea, but the power is in the implementation. That this macro language is implemented in Java, and it's integrated so with the JavaDoc. So you can use these macros in JavaDoc. You just have to configure in your Maven or Gradle project to use this Tuglet and the Doclet, which uses the macro language. You can use it with a Java, which is with Java source. You can use inside AsciiDoc. There is a plugin for that, and we will use this one for the demonstration because it's integrated into the IntelliJ. So whenever you edit something which is in AsciiDoc, then you can immediately see the result with the macros evaluated on the right side. It's integrated into Maven, so you can use it as a Maven extension, and then you can use these macros in the POM files, and with that one, the POM files can be shrink very much, and they become very, very simple and small and much more readable than the huge XMLs. It's a matter of taste. I like it, and it's also, just for fun, was integrated into Word. So you can have a Word document, a docx format file, and then you can ask Jamal to process it, and every macro which is inside the text will be solved and processed, and then you will get a Word document which contains the processed files. And what kind of macros do we have? Well, we have a limited set of core macros. We will see that. We have a snippet library, which is very much aiming towards documentation. And we will look at a lot of examples of those. But in addition to that, there are other macro packages which can help you doing scripting. So you can have scripts inside your document and do some calculation while the document is processed. And for that, you can include Groovy, Ruby, JavaScript, Java, and, well, even BASIC. I didn't list it there because many years ago, I wrote a BASIC interpreter in Java, and that's also integrated into that. It's also integrated with PlantUML. It can handle YAML files, XML files, fetching data from a YAML format or from XML. For the XML, we will see an example for that because we will fetch the version and the artifact ID and the group ID from a POM XML into the document. So whenever the version changes, the document will also change automatically whenever it's compiled, and it will show the latest version that the documentation is about. So we won't forget to update the version of the document. And you can include PlantUML diagrams, and there is an IO package with which actually you can just start any external program, so you can integrate it with any external graphic creational tool or whatever. So let's do the demo. And for that, I have an IntelliJ project that you can see here. And don't worry, I will enlarge this part because that's where we will work with this one. This project is not really interesting what it is. It's a source body. It can be used to compile Java source code, which is inside the Java source code during the runtime, and then load the resulted classes very easily. It's a functionality which is provided by the JVM for the runtime, Java runtime, but using these tools, actually, it gives a fluent API, so it's very easy to use these APIs with this tool. What I will look at is the documentation, and it's posted on GitHub, so it has a README ADOC file, but I'm not editing the ADOC file, I'm editing the ADOC.jam file, which is the Jamal version. So it's extended with YAML macros. And here you can already see some YAML macros, which probably seem very cryptic right now. And but let's have a first look at the ASCII doc file, which is generated. And conventionally, we are editing this ASCII doc file. And I will just copy this ASCII doc file here instead of the YAML file. And if there is no macro, then it's just that it is. And I will cheat a little bit because it's in Git repository, so I can just insert the macros, just resolving the definitions, and then I can see where it is changing, and I can go that way backwards, inserting back all the macros and showing the things. But first of all, let's have a look at what the problem really is with this source code and documentation source code. One is that if I am looking at this code, it's okay, it's great. But if there is any change in the file, and then this has to be updated. And actually this source code is coming from, if I'm looking at, let's say, where it is, it's actually coming from the test demo file. So if I look at here, then I have, oops. I have this, this code here. And it's denoted with this snippet callback compile. And these are the lines of the snippet. And instead of copying it all the time, I have to ask YAML to copy it to me. So what I can say is, and I'm changing back, that this is a numbered sample, simple compile. And okay, but what is a numbered sample? It's not defined. Yes, because I also deleted the definition of numbered sample. And where is numbered sample? I will change it here. And oh, yeah, it's here. Numbered sample is a listing of some source code where it says that it should number the lines with this format. And it should also trim the lines, because if you look at here, I have here a lot of spaces, and I do not want to have these spaces in the documentation, so it trims the lines. And then I am fetching the snippet with the snip macro, which is here. And the $x is the parameter of the numbered sample. It doesn't need to start with a dollar. It's just a convention. I can just write that. I can change it easily. And that now it becomes very simply $sign. But then if I change it, then it works again. And I fetch it, and then I also have a sample which is practically the same, except it doesn't number the lines. And every macro which is opened is also closing somewhere. Numbered sample is defined with the macro define, and then I can just simply say that here, simple compile. And simple compile is a snippet which is here in this file, not on that one. Sorry, that's the output in this file. And it's called callback compile, and it's a simple compile. That's a different one. Sorry, then simple compile is here. I shouldn't, yeah, of course. It's here. But the same thing is true for the other things. I just mixed up two different snippets. Every snippet has a name, and I can refer to them. And to save up some time and compilation, the snippets are collected. And so not all the files are read by the macro. It says that snip collect from this directory, and then all the files are read, and then all the snippets are collected. And also, if I look at that, source body is written like source and body, but if I am making a mistake and I'm typing them differently, then I have to pay attention that I'm typing it all the times all the same. But instead of that, I can just define that SB is source body, and wherever I'm using the macro SB with the macro start and macro ending, then it will write source body with the right typesetting, with the right capitalization. And I can use it at many different places. Now, the next thing is that we have here dependency parameters. And these dependency parameters, now it contains this version. And it also says source body, and the group ID is com.javax0jamal. And if I change any of these, then I have to change it in the documentation. But this is something which is in the XML file, so I can change it. And then I can just say that it comes from the POM file, and I have here an XPath. But the POM is a macro, actually, which is not defined. So again, if I look at here, I have errors at the start. Instead, what I can do is that I define this macro that I want to snip an XML. And this XML will be called POM, and this is the file name. And afterwards, I can use this POM as a user-defined macro, following with an XPath afterwards. And then here I have the group ID, the artifact ID, and the version ID. And if I am opening the POM file, and just for fun, let's say that I am changing it to from snapshot to final release, then it will automatically update the file, and it will say it's a final release, even with the typo that in letter A is missing. Okay, now let's see what else do we have. Here we also have some source code. And then I can say that, okay, I want to have here a source code, which comes from the simple compile. But I am interested only in the line which contains the pattern, my class space one or more equals, and so on. Because if we come to simple compile, let's have a look at the code, the snippet in the test demo. Simple compile, we are here. In the documentation, we were looking at this source code above here. And now we want to talk about the different lines of this source code. And therefore, we are having it here on this line. And then I am saying that from all the source code lines which are here, I just want to keep one. I kill all the lines, but I want to keep one which has the pattern, my class, and so on. And also I go on, and then I can also here use the snippet. About the API doc, I can change here as well again and again. And then I here have a macro, which is a counter. ASCII doc doesn't really help me to number the chapters, but instead of that, I can number the chapters with Jamal. I can define a counter, which is also in the snippet handling macro library, and I can say that I have a counter which becomes a special macro because whenever I use it, it increases its value. And I say that the format should be the $D, which is very usual coming from the standard C library for 40 years ago and still used in any other languages, a dot and a space. And then we just get here, get compiler object. I don't even need the space here because it's already in the format. And then I am numbering it. And the next time I'm using it here again, let's use it. If I am inserting a new chapter, like let's say I am inserting a new chapter, why not? And yep, I am here making something wrong, but then what do I do here wrong? I don't know, whatever. If I'm just inserting a new chapter, bear with me, I was making mistakes with the ASCII doc formatting. I don't know what it is. You can see that we have a new chapter and that becomes 2 and it automatically, the counter goes on and 3 at sources is 3. Well, but we don't want that. Okay, and we also get these source codes. And then this SRC is defined above, and it just says that SRC number N is a source code listing. It's ASCII doc. And then it says that I want to have the snip from APIDoc, which is called APIDoc. And we can go there very easily because we need APIDoc. Where is it? It's still in the test demo. All the samples are from the test demo, which actually executes during the test. These are test files. And we are just fetching lines from this snippet. And I am taking the lines from N to N, very obviously only one line. And then from this snippet code, this is here, and then I am ending the source here. So when I say SRC8, then actually I'm taking the APIDoc snippet line 8 formatted as Java source code. And every small step here, what we see here is just fetching another line as we go through with the explanation how the API works. I'm showing the source code here, which I'm just taking from there, and we go on and go on. Of course, if it changes, then we have to update the documentation. That doesn't save us for us. And also an interesting thing that what it says that this implementation, it's very specific. It's a very deep, actually digging deep very into the Java API, and it may not work for future Java versions. It may not be compatible with those. And it says that it was tested up to, but which version? Well, actually, most probably the version that I am running when I'm compiling the code. But this JVM version is defined in the source code. So if I'm looking at the JVM version, it's in the compiler. So I'm fetching a configuration parameter, as I was talking about in the examples, in the presentation I'm talking about. I'm fetching a configuration parameter, which is the JVM version and the Java version, and it says it's a snippet line, and which is a one-line snippet, so I don't need to use end snippet afterwards. And it says that JVM version, that's the name of the snippet, which is actually right now is the same as the configuration parameter, JVM version. And when I'm using it, then I'm using snip JVM version, so it's the snippet, which is the whole line, but from that I am only interested in the part which is the number, and this is a regular expression there. So it's very easy to fetch just a parameter, a version. And if I'm look at it, then where is it? I will find it somewhere here, but it's written there that it is actually the version which it works. Yes, of course, it's in the note. So that get binary name implementation supports JVM bytecode up to 36. So it's fetched automatically from the Java code as I am editing this file. And again, here we have a snippet, which is the line 14. I hope I changed everything. No, we still have here the 13, line 13. And other changes, which I will just revert at the end. And generally, I was showing many features, not all the features, but many features that can be done. And if I just reverting this file with, let's say, git rollback everything I did, then everything is Mavenized here, or sorry, Gemalized, so Jamal macro extended. Everything is fetched automatically. That can be fetched from the source code. Nothing is copied by hand. So if anything is changing in the source code, then it will also change here. And also, let's just set back the POM because you still see it's here. It's was changed. So let's do the rollback here as well. And it's automatically, where is the POM file? It should be automatic, the new one. Never, there is a caching mechanism. If the file doesn't change, then it doesn't update the right side, but if it changes, then it automatically updates everything. So let's go back to the presentation and let's wrap it up because we are slowly running out of time. We have a few more minutes, but still I don't want to be, it's better if I'm a little bit shorter than if I'm running out of time. So what is the summary and the takeaway from all this presentation? The very first thing is that documentation maintenance can be automated, partly, just like coding cannot be fully automated, luckily. So there are still needs, there is still need for developers, and so we have jobs. But document maintenance can also be automated. Document as a code, so using ASCII-doc or some other markup, but I recommend personally ASCII-doc. And using CI/CD, storing the document, the program documentation in GitHub, different versions, having review processes, very similarly as we have code reviews, is a very good thing. It's a good start. And apply CI/CD, and let's try and apply everything which is possible and use the automation if it's possible. So you should apply things like try, don't repeat yourself, solid, wherever it's possible. I mean, it's mainly a joke because I don't think that you can apply a list of substitution for a documentation, but generally the principles are the same because whenever you say that, why do I do that? Because I write code which should be maintainable, and when I'm writing documentation, then I have to, and of course the code should work. That's two different things, and sometimes these are contradict each other. And the same engineering compromise is there with the documentation, because you should write a document which is easy to maintain, but of course it should deliver the information to the reader, so it should run in the brain of the reader. And these are sometimes contradict to each other, and therefore this is the code as a document. The great idea that, well, the document is not like a conventional document, like the code is not a conventional code when we were coding in machine code. I was doing that when I was young. I was writing in assembly, and then I had to manually convert everything using a printed table. No, it was not even printed. I had to type it with a typewriter because we didn't have printers that time. And then it was a laminated piece of paper, and there were the codes for the assembly, and I had to look at the hexacode, and then I had to write down the hexacode, and then I had to type in on the console the hexacode into the machine so that it was running the code. It was very tedious. Today we have much better tools for that. We are programming in Java, even in Rust, and then everything gets compiled. There is a JVM that runs the code. So it should run machine code, but we should make it maintainable. And the same way, document is not a conventional machine code. Machine code, in this case, the document as it looks, visible, and the reader is reading it, but we should have a source code for the document, which is then transformed into the readable, processable CPU reader, CPU processable output. So when next time you need to write some documentation, then think about this tool. And even though if it's easier to copy paste manually some information at the first, but then the next time when you have to update the document, then it's easier if you invest it a little bit more. In my estimation, it's like 10 to 20% of the writing the document. There is the extra effort that you have to invest to, instead of putting the values from the source code into the documentation, put a kind of reference, a macro, which is fetching it. And then next time you need to do anything like that, update the documentation, it will be done for you automatically. And I think for the second release, the second version, it will already pay back. So thank you very much for your attention. And if you have any question, then I'm ready to answer the questions. I'm not logged into Discord at this moment, but afterwards, after the talks, I will log in and I will have a few minutes to stay online. Mm-hmm. And I'm ready for the questions.
Thank you very much, Peter, for your fantastic talk. And to be honest, I don't see many questions in the chat. But what I see is that we have a comment, very grateful comment from Tardis Maya. And it says that Jamal is the below tool for documentation as code because it allows to generate plant UML diagrams from the textual representation. So I suppose you have sincerely yours subscribers and sincerely yours, let's say, users of the tool. So that's fantastic. So from your perspective, as you said at the very beginning, you've written a couple of books already and use your tool extensively. From your perspective, roughly, how much time does it save to you?
If you are writing a whole book, then it saves a lot of time. I cannot estimate how much. And what is even more important, that it does not only save time, but it ensures that the book is consistent. So the first edition of the book, I didn't have this tool that time, was Java 9, about Java 9 with Pact. And during the editing, I did not, and the editors did not discover all the discrepancies. So I am writing the chapter, I am writing some demo code, I'm updating the demo code, I'm changing the source code, I am updating the code into the documentation, and some of the code parts were not updated. And then the code doesn't work for the reader because it's inconsistent in the book. And we had a problem with that. And when I was writing the second release of this book, second edition, in a book it's called edition, it's a second edition of the book, then I was changing for a different tool. It was still not JAML because that time it was not mature enough, but the snippet macros were not available by that time. I was using a different Python-based tool, which was automatically copying the source into the documentation and updating the documentation. And I can guarantee that when I was typing maven clean install, then it was on the root of the project of the book. Then it was running all the test code, all the demonstration code, updating all the documentation, compiling all the documentation. So at the end, I was getting from ASCII Word documents, and these Word documents were containing guaranteed the snippets as they were and as they passed all the tests in the source code. And it was guaranteed to be absolutely consistent. And this is something which is beyond any value.
Definitely, I can't agree more that it's a fantastic opportunity to have code and let's say in the documentation in the consistent state. If you don't mind, I'd like to ask another question. So we have a lot of markup languages for drawing diagrams, and PlantUML is, let's say, only one of them. What else we have is, for example, Mermaid. So what markup syntaxes are supported by YAML at the moment for drawing diagrams?
Well, actually, you can support any of them. Very simple. The thing is very simple. PlantUML, I selected PlantUML, and I created a macro package. YAML itself does not support PlantUML. There is a macro package, and if you put this macro package on the class path, then it's automatically recognized and taken by YAML using the service loader. Java developers know what a service loader is. And then the PlantUML macro is there, which is written in Java. And this PlantUML macro is just taking that, okay, the macro has an input, a part of the text, which should be PlantUML formatted, and then it invokes PlantUML to generate the diagram. And the return value of the macro, which gets into the text, is the reference of the SVG file which was generated. But if you have any other different, like Mermaid doesn't have a Java API because Mermaid, as far as I know, is written in JavaScript. But you can execute it as an external command. YAML by default doesn't execute just any external command because that would be absolutely insecure. You download the documentation and it sends all your money to some different account. No, but if you have installed Mermaid, you can configure how to execute Mermaid. You can, in the YAML configuration, in your user local or a global configuration file, you can create a symbolic name for this execution. And then you can write a very simple macro which says you don't need even to program it in Java. You can write it with YAML itself, define things like that. And then you just say that I want this text, which is the parameter of the save into a file. I want to execute Mermaid for this external file. It will run. I get the output of the executing things, and then I can reference the generated file. And you can insert it very easily without really programming any line of code, only writing macros. So PlantUML, and I'm not planning to integrate more things because it can be integrated using the existing tool. PlantUML was there as an example that you can do that very easily. But if you really need Mermaid, I didn't need, and you want to implement the integration, I'm ready to help you because I'm very happy if anyone is starting to use some things. And this is the problem with my open source project and probably for others as well. Many times people are using and don't give any feedback. And I don't have an idea how many people are using my tool. And I don't know if I don't get any feedback because everybody is happy with it or because they just don't use it. So I'm happy to help. If you want to integrate Mermaid and you get stuck with it, you can ask. I will help.
Yeah, definitely. I'm just asking because, what I know is that diagrams which are generated by plant UML are a little ugly. They are red and yellow, but
that's true,
diagrams
yeah.
which are generated by Mermaid, they are fancy, they are shiny, and they very colorful. Last one question from my side because we don't have any other questions anywhere. So regarding integrations, for example, may I include Jamal into my build pipeline, for example, as a plugin into Maven or Gradle builds, just in case if I, for example,
There is a Jamal plugin version of Jamal, a Maven plugin. So you can invoke Jamal as a Maven plugin. And since Jamal is written in Java, you can just invoke it from Gradle very easily. You just have to put it on there is no specific Gradle plugin. Very simple. I never really learned Gradle to that level. And I'm more a Maven guy. And I did not write the Gradle plugin. I just wrote the Maven plugin. And you can include it. Yes, absolutely.
Awesome. Thank you very much. I see Igor has joined us. So, Igor, what's your impression regarding this talk? I'm really impressed. I think that I'm struggling a lot with documentation on my current project, and I think I may try to start using it here as well, because we have a lot of microservices, and in every microservice, it's necessary to have, let's say, 20 lines of code how to use it on GitHub, and in the README file, what we ordinarily do is put small bit of code, just let's say add this configuration, and it will work. It would be nice to have this documentation constantly in sync with what we have in code, because we sometimes changing something and completely forget about changing the documentation, especially for newcomers.
So I guess your thoughts. I'm thinking in the same way as you. Why? For me, documentation I told before, and in previous talk when I highlighted this one, such kind of helping hand, and it continuously changes. We're changing code, we're changing, features, we're changing sometimes logic, and what a developer needs. Go to the code, go to the Confluence, spend some time, rewrite, and did he do this? Nope. Usually it's have no time, because you need to write a test or read something new, and you don't have a time. Frankly speaking, you don't have desire to do this. Yeah, and with such kind of tools, it's easily can be solved. Because as Peter highlighted, your code will be broken. You will not have a chance to commit while you fix all this. And I guess it's very, very needful, such kind of tools for team leaders, for future team leaders, or for seniors who growing up and thinking about his milestones, how to do something helpful for project. Yeah. So if somebody will introduce in his project something like this, it will be very, very achievement in the future. So very, very good tool. So Peter, you highlighted that you can help for if somebody ask about this.
Yes,
Am I right?
absolutely.
Oh, so we need to share context and colleagues who watching us. If you're thinking about creating something grateful, please take a look and contact Peter if you will have questions. From my side, I guess I will need to review and think about the question in my project, something like this, because it's really time saver for all of us.
I'm lucky that I have a name which is very rare. And at most of the places, my family name Verhas, without any accent. because originally there is an accent on the letter A in the Hungarian, but without any accent. That's my my handle on Twitter. That's my handle on GitHub. So you can find me. And Jamal is an open source Apache 2 project. It's on GitHub. You can ask questions there, or you can find me inside EPAM if you are an EPAMer, or you can write me an email like peter@verhas.com. Very easy email address. And
I believe that somebody will contact you soon because it should be used many of project. Okay, so our discussion can be proceed in the Discord. The links we have in the Alex, can you please copy paste link in the chat?
Yeah, I will do that in a minute. Give me a moment.
Sure. So, colleagues who are watching us, please join in Discord and ask Peter about documentation. Of course, you can discuss about these tools, about these utilities, or something different, because best practice for documentation. I saw in presentation, Peter, you highlighted use solid, use dry principles in writing of documentation.
yeah,
It's
so
great.
Is a joke kind of, because how, yeah. But yeah, you should
but
do
it's
it.
working
Yeah.
not only for code, for documentation too. Because as for me, sometimes I'm reading documentation and see that I duplicating something here, or my colleagues, and I always talking, please put links, not use duplicate of text. You will need to explain and make changes. Why you need duplicate and on all things. So it's good patterns. So, colleagues, if you know some different patterns for documentation, share with us. It's very, very interesting. Okay, colleagues, we can move to the Discord, and I'm going to present another one speak that going happen soon on our platform.
Thank you very much.
Thank you, Peter. It was
I'm joining now Discord, and I'm leaving the studio. Thank you very much. Bye-bye.
Thank you. See you later. Colleagues, I very, very hope you like it, and let me again remind you about what happens here. This is Java on conference, and organizers are community, MGC Modern Java community, JaCoV community, and mini community Vitebsk. Also, our general sponsor is EPAM, and we're talking about Java-related topics, very, very interesting and smart and modern. We have two streams. Here is orange stream, and we have purple stream in parallel. All links in the description of this video. Today we already covered interesting topic with clouds, and with documentation. We discussed, of course, on this orange stream and on purple stream, we discussed documentation as tests and how to improve and save time for writing documentation with Peter. You can, of course, join him and improve your project. And our next topic going to be around revolution in Java. What do you think about revolution in Java? What is this about? Hi, Dima.
Hello. Nice to meet you.
Yeah, for me, yeah, I'm with big pleasure. Frankly speaking, we're talking about virtual threads.
Yes.
Rather often.
Not only virtual threads, but applied virtual threads.
Yes, about, of course, applied virtual threads. Most of us, I mean, for me and developers working on earlier versions of Java, I mean Java 8, yeah, and virtual threads, it's Project Loom, it's just only introduced as a view in Java 19. It's not, it's just now. Colleagues who don't know about virtual threads, read about them. It's very, very important topic. And Dmitry, can you please tell, because your presentation, your speech, not about virtual threads, but about usage of this.
Yes, exactly. So yes, so in this talk actually, virtual threads has been around for some time. So it's not a new concept. I mean, there has been virtual threads like Fibrous and so on in different language and implementations. But for Java, yes, this is a kind of I would say reincarnation and revolution, because there was an idea of green threads back in those days of Java 1.2, I guess, or something like that. Please correct me if I'm wrong, but the idea is that yes, thread is a heavy resource, and working with threads is hard. So everybody who was able to read and understand the book of Brian Gertz about multi-thread programming, parallel programming, is really a hero. But once again, working with in parallel is hard. But still, we need somehow to get the performance. And for that, actually, we have all these ideas of reactive programming, which is like, solve the problem in some way for us. But it tends to be that it's hard. And well, now we are back to normal programming. I would say normal programming model that we learned from school. And this will somehow help us to not to get that programming so hard. So yes, this might talk will be about that thing, and the idea is that it's not just about something hypothetical. I will show it exactly on the product I'm working on. That means that it is already it's still some of part of our technical preview, but some of them can already be used even in production. So yeah, that's what we'll talk about. Yeah.
So you are a part of revolution. You're doing your revolution.
Just right before, this morning, I have committed some code in the revolution. So yes, I'm happy with this.
Wow. So, colleagues, you asked me about this topic when it will start. So it's now. Share the link on our translation for your product. It's very interesting.
I need to share the screen, I guess. Yes.
Okay.
Yeah.
So, colleagues, I want to remind you that you can ask questions in the chat here on via community or on Discord. So please write, and Andrei will help and read these questions, and Mykyta will answer them.
Thank you so much.
So, okay, let's go. We are muting Mykyta.
Thank you so much. Yes. So once again, this is the talk I'm going to do today. So it's going to be about the product I'm working on. So I'm really happy. And since this product is mainly contributed by Oracle, I really have to show you this slide because, things can change quite dramatically. That means that if you take any business decision based on that, just check once again if something has changed, because this is something that may happen. So my name is Dimitri. I'm part of work of Oracle team. I'm working on product Helidon. So these are my, so you can write me on this channels. I read them the most, you see. So the first part, you see, I have upgraded my handle. So the first part is tweet handle, and the second part is Mastodon handle. So I'm mostly answering questions there. So if you have any questions in both of the social networks, so I'm going to be really happy to answer them. Yes, and once again, I'm part of the Bulgarian Java user group, so co-lead. So I'm now talking to you from Sofia, wonderful city of Sofia. It's quite warm here, by the way, for the season. So it's plus 13. It should have been snowing, but it's like nice here. So I'm sending a big greetings to all of your community from our community. And I really like that this conference is organized exactly by the community. So it's developers for developers. So great. So the most common task of modern development is actually written on this slide. Yes, so microservices have actually gained like big respect in the community. That means they're not suitable for everything, but for certain cases or certain scenarios, they are the best choice. There are a bunch of talks about that on other conferences, on YouTube, whatever, well, everywhere, in the discussions, in the chats, and Telegram channels everywhere. So I'm not going to dive into why microservice is good or bad. I'm going to say that, for example, we need to create a microservice. And what would you do? So you have chosen that microservice architecture is for your project, is the choice for your project. How would you create a microservice? Well, I guess the most of you will say, oh, I'm going to take the Spring Boot and just do it. Like, this is the obvious choice, I would say. And you'll be completely right. Like, 70% of the code now is written in the Spring Boot. And yes, it's wonderful product. It's nice. It's good. There's a big ecosystem about it. But, well, there's one issue here. Is for me personally, it's an issue that it's not standard, which means that, like, for example, things can change dramatically and you can't influence them. So, or you can influence them mostly as a committer on code. So just go there and try to commit. Yes, but, well, it's not a standard. Well, it's a de facto very well accepted, but it's not about, standardized code. So that's why there was a big initiative called MicroProfile. And this is exactly an open source community specification for enterprise microservices written in Java. And yes, the main idea is that whenever you create your microservices, if you follow this specifications, they're going to be portable across multiple vendor implementations. Currently, it's hosted under a nonprofit Eclipse Foundation. That means that it's not like bound to someone personally, and there are a lot of participants there. So it's like Oracle, of course, IBM, Red Hat, Payam, Somitron, even Microsoft. By the way, Microsoft is really active now in Java world. So yes, they're contributing a lot, and they're also part of this community as well. So so these specifications are released well, quite often, like 4 releases per year. Once again, you have to understand, this is not an implementation. This is just a document with a set of TCK tests, which are there for different vendors from all those participants, like as I mentioned, to deliver their own products following the specifications. So you can find more information in MicroProfile.io. So that means that all of this main 13 specification are specially bound for the microservices world. Many people will say, okay, this is yet another Java EE, which is heavy, ugly, and I mean, well, it has all the negative from the past. Even many people will see this, say, "Oh, yeah, it's another EJB." Well, no, this is not. Yes, there are also two specifications, but if you take a look at those specifications, they are really, I would say, made for a microservices world. And microservices, since they are, I would say, well, a good example of a distributed computing system, like exactly from computer science definition of distributed computer system. That means that, for example, they are acting independently, they can fail independently, and they are all building like, something bigger than just a combination of this project, of each of the elements. That means, for example, if something fails, you have to care for how to do this the correct way, how to handle this the correct way. So that's how you have the fault tolerance. It's a specification, for example, that describes how would you behave and how your microservice should behave if the other side has fallen, for example. You need to trace, for example, one business request can have many microservices included, and must have the ability to trace it. You have the security with job propagation. You have health check just to check if the service is up and running and take your decision. For example, should I connect to this service or should I connect to another service? Even the configuration, it's not only the Java code, even the configuration itself is portable. That means that we have the decision that, for example, we want to switch the vendor. For example, other vendor has provided better conditions for us for our product. So maybe better support plan, better financial conditions, or maybe some benefits. And I want to switch it. So you just not part the code itself, but you also part the configuration, and it's also portable. So yes, this 13 main specification, although they somehow overlap with Jakarta EE specifications, but they're still made specially for microservices world. And that means that some vendors have to implement them. And actually, there's one thing about them. It's nice that you have this specifications. It's nice that you have well-defined APIs and good. But what if, for example, do we ever think about the performance here? Actually, not very much, because all the APIs that we have are blocking. I would say blocking. That means that in fundamental way, they ask you to block whenever you have the wait for this or a certain function to execute. And nice, let's have a look actually how can we think about performance in a fundamental way based on a product which I'm working on, which is exactly actually following the ideas of standard approach in microprofile and non-standard but performance approach of it. So our Helidon, so it's a microservice framework and has a very easy approach. So underneath you have Netty, which is well-known reactive service, reactive web framework for dealing with the network connections and delivering information over over network in a reactive way. So web framework. And to make it really cloud native, so we have a layer on top of it, which we call Helidon Reactive. So it exactly cares about, fulfilling all those specifications that I was telling you, like, for example, to care for health, for tracing, for metrics, for configuration, etc., etc. So, but as a framework itself, it was built in a reactive way. So I'm going to talk about a little bit more about it later. And to deal with standards, there's on top of it, we have this layer of Helidon MP. So that means that you write your microservices following the ideas of microprofile, following the specifications, and this way you make your code portable. That means that, for example, if you have written your code on some other framework, like, I don't know, Open Liberty or Quarkus or whatever it is, and you want to switch to Helidon because, for example, you have better condition and better support plans, you don't have to rewrite everything. You just drop in your code and it will work out of the box. So that means that technically, Helidon itself is like two different products. So Helidon SE is a fully reactive framework, which follows the functional style of coding. So it's reactive and non-blocking. That means that it really cares a lot of performance. It has very tiny footprint because it's so small. And, it's pure Java. There is no like injections, dependency injections, all that stuff. So the only annotation there is used is override. On the other hand, Helidon MP is declarative style. That means that even those specifications from microprofile I was talking to you, they are all highly inspired by Spring Boot. That means that you just put some annotations on your code and the magic happens. So that means that writing the code, so you just annotated your POJOs, and they automatically become microservices or endpoints or configurations, etc., etc. So yes, that means that in a fundamental way, Helidon SE is reactive. Once again, definition of reactive, the best one. I'm not going to dive into it a too much because there also talks about it. But Reactive allows you non-blocking access, a non-blocking way of coding, and that means that you reuse your resources as much as you can. So on the other hand, in Helidon MP, all the API is done blocking. That means that if you call something, it will simply block and wait for a result. There's some APIs that allow non-blocking access. I'm going to talk about it later, but in general, you write your code in a plain old way, as I, for example, was learned in school. So you make a request to a function, you wait for the request to be fulfilled, and you just get the result. Yes. So just to mention about this product, let's jump a little bit into Helidon MP. Once again, if you use Helidon MP, you follow the micro profile, but you get a little bit more. So that means that you get not only the micro profile specification implementation. That means that you can annotate your code in micro profile way, and it will do the expected functions for you. But you have a little bit more. So in MP, there are also standalone specifications, like, for example, work with GraphQL, the implementation of Saga pattern for LRA, and working with reactive streams and reactive messaging. But you also have the CDI, you also have the WebSocket. Yes, you get a big infrastructure. You also work with a database, for example, with persistence. So that means you get a little bit more. And if you can see here, I always love this picture because the footprint is really tiny. But the good thing is that we're giving 3 ways of distributing your product. So one is a plain old jar file, so fat jar with executable. The other is we support JLink, custom image generation. That means that Helidon itself was built in the post-9 world with Java modularity included in it. And that means the code itself is fully modular. And as the code is modular, you can just throw away the code you don't need at all. And the other option is native image, because everybody is familiar with GraalVM native image. So I'll just put in some light in my room. So that means that it can generate native image. It's a pure executable. It's very fast, cool, but with some limitations of language. And you don't have the optimizations that JVM can provide you running from time. But it has wonderful startup times. And what is good is that's we are we are the only one who support CDI. CDI is a constant dependency injection in GraalVM, like following the full spec. That means that you can just drop in all of your CDI extensions. This is, by the way, the extension mechanism of Helidon. If you don't have any special features or something, you just drop in CDI extensions and it will simply work, even in GraalVM native image. Now it's fully JaCoVified. So if you just small product positioning, as I say, if you want to start working with Helidon, now it's done very easily. So you just go to the Helidon.io website, and there is a starter there. And the starter allows you to generate your project. Another way to do this is to use our CLI, actually. But I'm going to show you a little bit later how to use it. So let's jump a little bit into the demo, just to give you a flavor what it is to work with Helidon. So I'll go to Helidon.io. Go to starter, and you see there's a startup, but it's not typical starter as other colleagues do. So we are following the idea of step-by-step generation of your project. So you just create a application, can be custom, like you can take how you process JSON. You can care about security, whether you want to secure your application. It will give you all the modules that you need. Once again, we are modular. That means that you just check the models you need. If you need some implementation, not in implementation, but delivering your application somewhere in the clouds. You can generate Dockerfile, Kubernetes, and for example, we are very much associated with a Verhas project. So Verhas is a way to run your application in the clouds. You can generate the descriptors there. You have everything, health tracing. It can be microprofile, micrometer. So you really build custom application. And if you work with database, for example, you have all the support here. So you just tick whatever you need, and that's probably it. So, but we will go back to Quick Start because this is the easiest way to create this project. So it's simply download it and CD downloads, I guess. Yes, it's in the downloads folder. And we will simply unzip the project and open it in our favorite IDE project. So let them give it some time. So I'll just put it here. Oof, wait a second. Where is it? So, yep. So what do you see actually? It's the flavor of it. It's very, very easy. So if you have a critic resource, you just annotate it with path. You just annotate, for example, with getter, like, get default message and maybe some custom messages. And yes, with simply 2 annotations, you get your microservice ready. But once again, if you see here, everything is blocking. So it's done in a blocking way. That means that you write the code just the way it is, and it simply works. If you want to get message, just get the message. It's really, really straightforward. To make it run, we just build it. So Maven, you can simply just clean package it, yes. But if you want to do it with better experience, for example, you can also use our special CLI. So if you download the Helidon CLI and run it with dev, so it will automatically track all the changes that you do in your code and rebuild everything for you. And once again, if you say a microservice, cloud native, that means now if we do curl greet, yes, it will work. It will give us the hello world. So as we expected here, for example, this is the greet resource, and we say for the default get, it will just give you response with hello world. But not only that, so cloud native means that you are really ready for health checks. You see it's up and running. You can do metrics. It means that it already out of the box provide you everything you need to run in the clouds. Open API, etc., etc. And that means that creating microservice in a blocking way and writing it in a declarative blocking way is extremely easy with Helidon. And it runs nice. It tracks your changes. You have all the tooling, which is good. So nice. But once again, there are some issues with that. And this main issue is that it is nice if you're mainly focused on portability, but it's actually, what about, well, if you're serving like average count of users, it's nice. But when it comes to performance, when portability is not so important, then what would you do? So in Helidon world, we will just use this Helidon Reactive layer. And this Helidon Reactive layer was previously called Helidon SE. And what does that mean? That means that we just throw away all this magic of the microprofile, all these annotations, etc., and give you the same, actually, specifications that you had to fulfill, but they are all done in the reactive way. Reactive way, that means that they are all non-blocking, they all respect back pressure, and they're following this wonderful reactive paradigm. Yes, but this becomes like a non-standard solution. It's much more performant. If you take a look at the numbers, So it really throw away all this overhead given by the context dependency injection, given by this annotation processing that you have to done for an application, all these extension mechanisms that you have there. They sometimes happen in the runtime, and they really eat a lot of your processing time. And yes, if you throw away all this stuff and leave only the reactive part, you become really, really performant. And actually, that's what, for example, is done. You'll probably ask yourself, okay, Helidon, we haven't heard much of it, but as it was developed mainly as a Oracle's internal framework for internal project, and then it was open sourced for the community. Once again, it was one of the first ever products which was open sourced within Oracle in Apache 2.0 license. That means that everything is available in the GitHub. So you just simply go to GitHub Helidon.io. Nice, good, because we now have our own organization. It's not affiliated with Oracle, so we have different repositories. It's an organization, so if you go here, and that means that all the issues, all the pull requests are here. It's all the discussion is done here, and most probably in the Slack channel, but it's not closed code. So it's already here, and you can contribute there. So we accept PRs. Yes, and if you give it a star, so we are very close to 3,000 stars. So if you give it a star, it will be really, really helpful for us. So, and if you once again remove all this, I would say, overhead, then it becomes really performance. And this performance is used in one of the biggest projects, for example, Oracle Hospitality. All the bookings in the world, you'll be surprised, are really, for example, for apartment, for a hotel room, for a cabin in a cruise ship, whatever it is. So you book it through one of the websites, but the booking itself actually go through a system called Oracle Hospitality. It's the most widely accepted system for booking, and it serves like millions requests per second. And doing it in a standard way with microprofile would have been just too much. You have too much overhead, which has to be processed. And that's why they did it fully reactively. So there are several microservices which are very small. Like each of them become of a 10 megabyte size and have served millions of requests exactly in this reactive way. How would you achieve this in Helidon SE? So we have decided that it's a good idea not to depend on anything else and to create our own reactive engine. And this reactive engine is created following the Java, 10? I guess it was 10, just correct me if I'm wrong. This concurrent flow API. So once again, in Java 10, they introduced these interfaces for publisher, subscriber, subscription, and for you to fulfill. And we have used them to create our own reactive engine for, reactive processing of many, many requests. So we have our own reactive operators, and as you see, they are all easily constructed using two main construction, which is multi and single. I believe most of you are familiar with Spring, so there you use Flux and Mono. It's the same in Helidon world, simply use multi and single. So that means that, for example, if you want several operations to be applied to some data, some set of data, or stream, I would say, of data, you just use multi. If you have only one element that has to be processed in a reactive way, you just use single. And Helidon has a very good set of reactive engine operators. So it's not that infinite in, for example, Project Reactive, but it's quite useful and good. So you can easily chain this operator. So you can just click publisher, then you have process this stage, and then you can compose them, for example, together to give a aggregated result. So it's easily done. Actually, the funny thing is that single and multi, for example, are following the completable future, so they're extending the completable future itself. So we're reusing a lot from Java itself, which makes it, once again, we're not depending on anything else except JVM. So, for example, why is that happening? For example, for banking solutions, you have to do audit of all of your dependencies. So we had this as an issue, and that's why we said, let us do our own engine. And actually, we're quite happy that this engine was contributed by David Karnak himself, who was, who is the father of reactive programming itself. So you will say yet another engine. Actually, yes, but it's one of the purest engines I would ever see, actually. And it allows us to do everything in reactive, and we compare to our competitors sometimes we're even twice as fast as the others. So, and as a result, if you have this reactive engine, you can create your fully reactive web server. So that's what we did. And that means that in Helidon SE, you just take a web server, it's fully reactive, and you start working with it. So actually, let me show you this in the demo. This time, we will use the same Helidon application, Helidon, but now we will create a project with it in it. And the same as in those in this starter, we just answer a few questions. This time we will create the flavor of Helidon SE. We'll use quick start with JSON, I don't know, pre-processing, for example. Answer some questions. We don't need the developer loop I've already shown you right now. So we will just create, we have just created the project, and we will just open it now, quick start. You see, it's very fast. And now you have the same microservice as I showed you, the same greeting application, but now written in a reactive way, following the reactive paradigm. So what you see here, it's just a main function. I hope you can, by the way, see my screen. So I have, I think that this font is nicely readable. So just write me in the chat if I need to change it, but I believe it's okay. So it's just a main function, pure main, nothing else. And in this main function, you create a web server object. You just configure it from somewhere. So it's following the builder pattern. And then it starts. As it starts reactively. So you see this single. So the single means that there is an object which contains the server, and you can work with it completely reactively. So when the server is ready, so just say the server is ready, and okay. In shutdown event, just print the message. Exceptionally, if you probably all have watched the famous Venkat Subramanian videos about what is functional programming, what is reactive programming, so you know there are three streams of events happening there. So there's the data, the control flow, and the exception flow. So that means that they, like, you know, have data, then you control the way it's processed, and then you have this exception flow. As if the exception happens, you can handle it gracefully. So that means if some server can't start, you exceptionally say, well, something wrong has happened. And then you just create a routing. For example, you just register a route for a service. And once again, the service is something extremely easy. It has only one function to override, which is the update method. So this is the only annotation that is used in Helidon SE. When you say, for example, for this greeting route, please use this handler. And this handler is reactive. So it receives only request and response. And as you see, it reactively processes the data. So if you have a request, for example, as JSON object, so it will return you a single. Single means that this is something as a reactive construction. Whenever it's done, you can say then accept. So whenever it's available, the next thing you will change is set on it is like update greeting. You will call this function, and whenever it's done, you see this completion awaitable here. Whenever it's done, you can return it, or if exceptionally something in the middle. Once again, I'm following the reactive programming here, a model here. So whenever something happens, just send an error. And you see, it's a reactive way of doing stuff, following the reactive paradigm. I'm gonna just start it right now. So the start, I can directly start it from the IDE because it's pure Java. There is no magic here. I don't need to make extreme scripts about it. So I just start it. And if I just curl the same stuff I had, it will do the same for me, absolutely the same for me, but now in a reactive way. I will still have the same endpoints, read the health checks, read the metrics, yes, but now it will be much more performant. I will give you numbers later. It will be much more performant, but as you see, it is a completely different paradigm. It's a completely different way of thinking. That's why, as you say, we say Helidon has two flavors. Actually, one is based on another, but still I would consider them for myself as different products because you just code it in a different way. And as we do this, it's really, I would say, it's just different. And if we go back to where was this demo? Yes, slide. If you go back to the description, for example, it's very much suitable for reactive messaging. So whenever you have a big flow of messages, and if you follow the microprofile reactive messaging model, so we have a wrapper over, like an abstraction over them, you can pass your message through different message brokers, and you can do it absolutely natively in terms of Java code. So you just create this channel, and you work with them in a reactive way. You can have multis, you can have singles. You just reactively process and like do maps, for example. Then you can pick a message from somewhere. Then you can just print it, use it for each. There's only one thing about reactive. Once again, this is a fundamental thing. Once reactive, you always have to be reactive. And what does that come from? You can't mix blocking code and reactive code. And here comes an issue, for example, with work with database. Currently, all JDBC drivers, there's an initiative, our RTDBC, which is reactive, but the JDBC drivers, for example, are blocking. So they have blocking API. How would you deal with them if you want to use them reactively? So we have cared for them and created our own DB client, which is like a wrapper over this driver. And it provides you a reactive API to work with blocking drivers. But these blocking drivers are like running a separate executor. So that means that you receive this way of asynchronicity. I'm not sure I did if this such a word, but you can work them asynchronously. So that means that you can do the same for web clients. So if you have to talk to another service, you can also do this reactively. So that means that to make code much more performant, to run it reactively, we have to do all the instruments together to be fully reactive. So we actually did it. And here we have this Helidon SE product. But the practice have shown that reactive programming is hard. Yes, it is hard. I'll be quite honest. And it's very hard to work with exceptions. It's very hard to troubleshoot, to debug, to unblocking code is a blocking code is much easier just to put a debug point and it will simply work. In reactive programming, it's not the same. So if the reactive programming is too hard, what would you do? So now you have only two choices. But here we finally eventually come to this revolution that actually is happening on our eyes. With this release of JDK 19, we have become the possibility to work with virtual threads, which were introduced in this research project called Loom. So it is really here. So it was released as a JAP like this year in the beginning of I would say April. Yes, April. So it already became something like, not just happening somewhere, something realistic. And what do you have? So Project Loom defines something called virtual thread. Virtual thread is an entity which actually by API copies the real thread. As you know, working with thread is hard. Threads themselves are like a very expensive resource, and you can't create too much of them. Because, for example, if you create like more than 400 threads on one machine, and you have only like, I don't know, 10, 16, I don't know, 20, for like 32 or 64 cores to actually work with them, most of the time they will be blocked and waiting for the resource to be available. And since they will be blocked, the resource will just stay and do nothing. And just keeping that resource is hard because all the stacks that you have there, depending on the JVM, can be megabyte to several megabytes of size. You have to keep them in your memory. And switching contexts is a hard operation. That's why actually reactive programming was introduced, because it's non-blocking by its nature. But what we have here, so you have two main categories. So the carrier threads are exactly those operating system threads that we had, and virtual threads, they operate over them. So virtual threads are really like mounted by the JVM over carrier threads. So when the virtual thread is blocked, so there's a scheduler who actually sees how the virtual threads are worked. So it's unblocked, it's like unmounted, and given to the resources given to another thread. Whenever it's available again, it's unblocked. The scheduler will see which thread should receive this resource and give to him. Actually, it's based on continuation. So continuation is also like a computer science structure. So it's based on that. There's currently no API available. And those properties are, and underneath you have for join pool for the carrier threads. So, and the main idea is that virtual threads, they can be millions of them. They are now became a cheap resource. They don't really block real threads, and they're threads by API. So in JDK 9+, they are already available as a preview features. So there's only like a little bit more new methods to the executors. So it's a virtual thread, or how to create a virtual thread. And once again, what is good about Helidon? Out of the box, we do support those threads. So it means that whenever we need to process the requests which are coming as a server from our clients, with one option, we can switch the executor, the thread pool that is used underneath Frenetic, from real threads to virtual threads. It's only one option. Currently we can, even with the second option, we can just enforce it. I will show it in the demo for you. That means that we can, out of the box, just change one property and already use the virtual threads for Netty executor. So what does that actually mean? That means that allows you to write the application which are blocking by their nature with performance, non-blocking or close to non-blocking, with blocking paradigm. So that means that all this bloody enterprise that you have in the world, which is written in a blocking way, following standards, can now be much better utilized for your enterprise application. But once again, there's one issue with Helidon. So we are changing the thread pool executor for the netty. Netty is asynchronous by its nature. And since it's asynchronous by its nature, it's exactly what I told you in the next slide. It's like putting an electric engine on a petrol car. So, you know, this electric revolution that we have now, so you can really switch, like, you know, the engine, receive big performance, but you still have the gearbox. You still have this, the way you actually architecture of your car here is still following the petrol standards, not the electric standards. Actually, I'm going to show you in the demo how it's done in Helidon, and you will see the difference. And we have decided, okay, since now we have this non-blocking, blocking way of writing code, and we have this, for example, a netty, which is asynchronous by its nature. And to care for all this asynchronous stuff, there's a lot of magic that is done there. Let us do our own server, which is fully blocking, and let the JVM decide how to manage the threads. And we have created Nima, which is the first virtual thread-based web server at all. So that means that it's fully synchronous. Even the code is there is fully synchronous. It's built from ground up. It's only using JDK and together with Java team. So we have some benefits here because we are one chat away from the Java and JDK team, from the performance guys and from the architects, and we're able to collaborate tightly with them. And we have created this server. So it contains, Nima is like a framework which contains Nima Web Server, which is part of the additional libraries. And it has performance, which is, you will see it later. So as Helidon is like, you know, based on this layered architecture, it was extremely easy for us to just switch the layer, which was underneath, from reactive to blocking. So that's why care for your architecture, care for the architecture that you have in your products that you do. So for us, if we have this layer, we're going to switch what had underneath. And we have completely rewritten some of the components. They're still in progress. Once again, it has just been released, this Java 1, like a few months ago. So we're really on the edge of the revolution. So we're rewriting all this non-blocking, non-blocking stuff, reactive stuff, to blocking stuff. And as a result, you know, Helidon has become one of the world's first consumers of virtual threads in a, I would say, applied way. So talking about virtual thread is nice, but we really do use them and apply them in real-world applications. So currently we support everything like HTTP1, HTTP2, gRPC protocol. We have to rewrite it, by the way. It's now performing very good. So WebSocket, it has testing, TLS and NTLS support. So it's very much extensible. You have access lock, you have support for CORS. You can serve your static content there. Telemetry, observability features are already there, and a lot of more is coming. But what is cool, it is all written using the latest stuff available from the JDK. There's no legacy underneath. So it uses virtual thread for performance. It uses enhanced switching for much cleaner and better readable code. Since we are framework, so we use sealed classes. They are really perfect for writing, you know, hierarchies of components for APIs and so on and so on. And we use system logger. So it's only JDK. So, and currently we're using this thread model. So for each usage, we have 2 virtual threads for connection and for data. For HTTP2, we have 2 virtual threads per connection, and 1 for if you need to stream something with HTTP2, you can have another thread. So, and all the routing is done in virtual threads and can block as much as you care. The JVM will take care of it. So why would you ever need this? Sorry, I have to switch my lamp off. I have not considered that it will get dark so fast. Instead of creating like this code, which is asynchronous, with a lot of, hardware. You just do simply blocking code that I, for example, was teached in school, and as easy as that. And as a result, we get the following performance. So if you compare to Netty, now we are a little bit better performing than Netty. Because once again, we just thrown away all this asynchronous stuff, and it's now fully blocking. Now the JVM, only JVM cares for that, and there is no overhead that has to be processed. But if we take a look at the Helidon MP, which uses blocking Netty underneath, and just replace it with Nima, the performance is times better than we have previously. Once again, the idea is not just to replace an engine in the car with electric, but to build a completely new platform which is suitable for the virtual thread environment. And that's what we need. And let me show you one demo right now. So yes, I will just open a project which is Helidon Loom. Yep, I will just close the other ones. Helidon is here, close the other ones. So I'm going to show you different ways of actually writing the same stuff and see their performance. So first of all, we have a very easy server which has two main resources. One is processing quick requests, it simply returns done. And other one is processing slow requests, it just slips some time and then returns something. That means this is an imitation of heavy load, and this is an imitation of fast load. And as easy as that, this is the server. We have two clients which are actually just sending request responses, and the same is written in a reactive way. If we take a look at the reactive way, so the service is really simple. So now you have the, you can imagine how it's done on in a reactive web service. So it's very easy. Just send a response. And here, because we are non-blocking, it was a little bit strange to see this executor, but it's just like imitation of blocking in a non-blocking environment. So yeah, once again, by the way, take a look how few code you have. It's just a main function. You can just run it. And the third option is the Nima option, which is exactly the same thread, but it's written, not the same thread, the same server, but it's written in a completely blocking way. You see how less code you have. You just create a server, and you just create an HTTP service, which is extremely easy. So you just sleep and send a response. You don't have to make all this fancy executors and so on and so on. And let us actually take a look at what we have. So I'll just show you the performance, actually, the difference. So terminal, I have a special Windows group for which conference, and what we have here. So by the way, I haven't shown you the main thing. And the main thing is that we can work with server, just changing one option. So just changing this option, we will enable virtual threads in Helidon MP. And here with no loop, we will just disable them. Once again, you don't change the code. You just change the executors which are underneath. And let us play with it. So what we have, just give me a second. Yep. So we will start the server with no loom option. It just starts the server, and now we will start the clients, which is Java jar. This is client slow. Yeah, we'll send request and response. Java jar client quick. So what will happen now? Here we actually start seeing that the slow response is occupying all the thread time. It simply sleeps, but the quick response are not able to be processed because the threads are blocked. And you see a lot of errors happening here. So the CPU utilization is really small, I would say, because the slow threads, they block the other threads, and the web server simply can't switch to other threads. And that's why you have a lot of errors happening, and the utilization of the CPU is really bad. Nice. So now, as an official option, we have this reactive way of doing stuff. So where is it? So if you write it reactively, what will you see? Suddenly, you are able to process the slow threads, which are, occupying a lot of time, but you still see that the quick threads are also processed. You start in an asynchronous way to utilize the resources of your processor much better. So if you do htop, you will suddenly see that your processor is nicely occupied with doing something useful. And you see, it really returns you a lot of responses with practically no errors happening there. So reactive way of doing stuff. Oh, sorry, my lamp is a little bit, I have to switch it better. Yep. It allows you to utilize the resources in a much better way by simply non-blocking way of doing stuff. Okay, but we see that saw that reactive is hard. Let us switch the Loom option on our Helidon server. So it's simply changing one property. So it's now using virtual thread, and what you see, suddenly of this 0 returns a lot of errors, we suddenly start utilizing the threads in much better way. It's really close to what we have in a reactive way. It's less now, but you see the JVM is getting hotter and hotter, so it's processed better and better. But you see that just switching to virtual threads as a pool allows us to utilize the resources that we have in a much better way. But once again, it's like putting electric engine on a petrol car. But even this helps us a lot in our framework stuff. But now if we put Nima on, so Java manage jar, we have to enable preview because in JDK 19, you already have it in JDK 19, but you have to enable a preview feature. And all of a sudden, the same stuff is done in blocking manner. You still start doing the same performance, or close to same performance, but in absolutely blocking code, which has no tricks. Like, for example, Netty has some tricks with the JVM. It uses some native performance stuff, operating system dependent stuff. And you start receiving the result. By the way, it's still research function, so it's not that very much optimized for Mac. On Linux, you will have better performance. So you see, just switching to virtual threads, the same code works much better and much more. It utilizes your resources much better than it had been previously. So this is the applied virtual threads. This is what happens like on our eyes. So we as a framework started using it in our system. So what is the problem we don't solve? We have 2 more minutes. Abstracting thread, abstraction itself, is when you use all the threads without switching the task. So microservice nature of using the resources is that we have small tasks which are running fast and which may have some, for example, some IO data reads. So they are not obstructing the thread. If you obstruct your head, there's nowhere you can get more performance. But here, if you are using small portion of thread time, and others think is like, for example, reading from database, you can still give this time which you're blocked to other threads. So the funny thing is that everything asynchronous in terms of operating system actually degrades performance. So if you do sockets asynchronous, they will degrade. So you have to block again. The same is for server socket. Blocking mode performs much better with virtual threads. So now the biggest challenge is actually to forget the asynchronous, because this way the code works much better. So we have to completely rewrite HTTP 2 and gRPC, but now they perform even better because once again, we don't need to use asynchronous stuff in those protocols. They're simply blocking. And as you see, we are rewriting the models right now. So the main target of this talk is that this revolution is actually happening on our eyes. You solve it with real numbers. And now for performance, you really have to unlearn to do reactive to get the maximum of it. So we're really short of time. So Helidon is a nice playground which we are having for our customers to use most performance available. So I took you to a small journey from blocking to reactive and now back to blocking, but with the performance of reactive. And if you want to learn more, we have a bunch of social networks, links, and whatever it is. Just go there and you will find all the information about Helidon, how we did it. And we are quite happy that our customers are so much satisfied with this performance change that we have. They don't have to rewrite anything. They just have to turn on one option. And Nima will make it even better because it's pure implementation of which is depending only to JDK, nothing else. And that makes us quite unique. So once again, thank you for this opportunity to talk to your community. And I believe that you will try it. And whenever you find issues, just report it. As we say, we are open sourced. Just submit an issue. Unlike other projects, we have even a special person who actually is on duty to care for customer requests and responses. Thank you very much.
Okay, Dmitry, thank you for your talk. We have a couple of questions.
Okay.
What do you think about future of reactive frameworks? Does it really make any sense now?
I would say, you see, for enterprise, no, not anymore. I'll be quite honest. But there are certain situations where reactive is better. So there's, for example, with completable future, if you send some requests to many services and you have, for example, function either of them, you don't have to process everything. So you can just have the first result and cut off the others. So there are situations where reactive is good. But once again, this does not cancel the reactive. I mean, you simply don't need it to write performant code. If you need reactive, use it. But my personal opinion that you won't need it so much time.
Okay, got it. Is there any way to do some kind of abstraction of virtual threads with Java 8 or Java 11? Because most of us are working with Java 8 or 11. And only
once again,
17.
There's no abstraction for them. So virtual threads are by API the same threads as we used before. So if, for example, the community somehow say, we will backport virtual threads to Java 8, you will simply have it available there. But once again, it's a very deep fundamental change. And you cannot abstract them. By abstraction, virtual threads are the same threads. What makes them really, how you say,
clear for understanding.
This is the fundamental thing, that they are the same. You don't have to change anything. Underneath happens the magic. By API, they're the same.
Okay.
But they have only one other function to change: is the thread virtual or not? So, is virtual? Yeah, this is the change.
And in which situation it's better to use real threads, not virtual?
Well, if you need to abstract, so exactly, if you really know that this particular operation will take all of the thread, for example, for a long time, you have a big computation to do. virtual threads won't gain any performance for you. Once again, there's a very nice talk by Ron Plesser on Java 1. By the way, Nima was presented with Ron Plesser as well. So if you go to this talk, he will tell you exactly what problems virtual thread do not solve. Like this is important. And here, for example, once again, we say what we don't solve, the abstraction. So if you use the thread all the time, but the nature of microservices behavior is that most of the time you receive a request or you have to go to database, for example, to search for some entity. You go there, and this waiting time, it simply do nothing. But the task itself, go search for database and return, is quite I would say short, and that's why you don't obstruct the thread. You are just using it, but now you use it wisely. So that's it. So that's why we are virtual threads applied, because this is something which is really suitable for virtual threads. Yeah.
Oh, okay, I got it. Do we have some drawbacks in virtual threads?
Well, it's still we had some, by the way, but you see, it's still not stable, I would say. So and it's still depending on operating system. So we are now mostly focused on Linux environments, and as I told you, for example, you even saw it in my data, but in my runs, that I'm now on Mac, and they are performing not as well on Linux as on Linux environments. I'm not sure how it's done in Windows. I know that in Windows there are issues. By the way, we found some issues in virtual threads by our customers using it on Windows, and we have submitted this to the JVM team, and they are now working on them. So it's still experimental, but we're on the edge of this revolution, I would say. With Java 21, I guess the virtual threads will go out of preview and will be production ready. And as they are production ready, all these drawbacks will be fixed. So that's why we are now exactly examining what drawbacks can be.
Do you know some timelines when we can try this?
Well, you can try it right now because it's already available in JDK 19. You only have to enable preview.
Okay. Got it. Thanks. One more question. How do you think, can Helidon replace Spring Initializer? Start Spring IO.
Well, we're working on that. Spring is a vast ecosystem, and competing with Spring is hard. But once again, it depends on what you search for. If you're a projector, like throwaway, do it once and throw away, then yes, Spring is awesome. But if you're doing something for a longer time and you need to follow the standards, or you need to port something from other platform, which is now actually, by the way, with this cloud wars that we have right now, for example, porting from one cloud to another is also an issue. For example, there in some cloud you're mostly focused on, I don't know, Quarkus-based stuff, and then you need to go to another cloud, which is forced more on Liberty stuff, for example. So the porting of this code is a problem, but you have to rewrite it. Some of the business decisions are taken there. And as for Helidon, it's hard, but once again, we have our own customers, which are very, very fond of it. And this big game changer that we have right now can, attract more customers. And once again, if you already started using MicroProfile, you simply don't need to do nothing. You just run this code on this environment, and it will perform better. So you get it for free, I would say.
Okay.
That's great.
Yeah.
Thank you very much. I'm just joined to you, and first of all, I want to say thank you. You're really making a revolution, and we are waiting for you making Java great again.
Absolutely.
Performance. So fantastic and very interesting. So, colleagues, I want to say that I mean, you, Dmitry, Andrei, and all who watch us can proceed with discussion in Discord.
Yep.
And already we have here a link. Andrei, can you please copy paste a link for right room in Discord? Copy paste in chat. So perhaps we will have additional questions there.
Oh, they want my birthday.
Yes.
Well,
Yeah.
I will choose random.
It's there. Andrei already put it here, the link. Colleagues who are with us, please don't forget to like video, or it's not video, it's a stream, and pass your minds about virtual threads and so on. And
thank you so much.
Thank you, Dmitry, that you found time and tell about this, because frankly speaking, not each day, but very often we're discussing what about virtual threads, how they making things, and what next. But we see that not only virtual threads introduction, but Helidon Nima, and you talking that Spring can be in problems in future.
Absolutely. If you don't apply them, yes. But once again, we rewrite it from scratch, so that makes us a lot of.
Sure.
Okay.
Okay, colleagues. Thank you very much. And all who want to proceed with discussion and have questions to Dmitry can join him in the Discord. Please use this link. And from my side, I want to say that this was a last amazing tech talk for today. Our conference ends, and we ready and want to see you all on our purple stream, where will be topic hour closed. I'm putting the link in the chat, so please follow us there. Let me put link here. So this is our purple stream. Very hope that you will share these links with your colleagues who was not able to join or was overloaded with job, because my colleagues was overloaded. I've received messages that I cannot view. And do you have a record? Yes, we will have a record. We will prepare short topics and will upload on the JaCoV channel. So if you don't subscribe, do this now. And you will not forget when this video will be available, and you will be able to watch again or share with your colleagues. And you see, we're talking about future of Java, not just simple things, but about future and future developers who will have a chance to work with the Loom project, with the virtual threads or something else, can start it do from today. And we provide for you the things that should change a Java world. So colleagues, see you in purple stream right now. Go on another stream. Don't forget. See ya there.